हेलो, a very warm greetings to all of you. आप सभी का हार्दिक हार्दिक स्वागत है, अभिनंदन है. Respected Chief Guest of the day, Professor N.S. Raghuvanshi, Director Maulana Azad National Institute of Technology, Manit Bhopal. Our guest of honor, Dr. Piyush Dua, Professor, University of Technology and Applied Sciences, Oman. Another guest of honor, Dr. Krishanu Vishwas, Professor, IIT Kanpur. Dr. Rajni Verma, McKinsey Postdoc Fellow, University of Melbourne, Australia. Director, CSIR-AMPRI Bhopal, Professor Abnesh Kumar Srivastava. All the distinguished guests of today's program, dignitaries which are present today from Navodaya Vidyalaya Samiti, Kendriya Vidyalaya Sangathan, invited speakers, researchers, scientists, students, teachers, professors, and everyone. Ladies and gentlemen, I extend a very warm welcome to all of you on this very special auspicious occasion to celebrate the 75th year of independence as Azadi ka Amrit Mahotsav and 80th year of CSIR at CSIR-AMPRI Bhopal with CSIR Jigyasa through this virtual platform. Let's be all be in the same vein as that of our nation today, and let's be the proud to have the celebration of this unique. It's of unique and first kind in the form of a webinar. With this, to start with the program, ladies and gentlemen, I would like to invite Director CSIR MP Bhopal, Professor Abnesh Kumar Srivastava, for his welcome address and opening remark. But before that, I would like to share the list of his achievements. Although the list is very long, but it is really very difficult to put them into the few words or to concise them. Dr. Abnesh Kumar Srivastava, he earned his Master's in Physics from IIT Roorkee and Master's in Technology in Material Sciences from IIT Kanpur. He holds PhD in Meteorology from IISc Bangalore. He is known for his knowledge and expertise in the field of materials, processing and characterization, semiconductor science, nanostructure materials, composite, and the list is very long. He has more than 350 publications in high impact journal with more than 5,000 citations along with his work, which is also highlighted in Science. It's our privilege to share here that Dr. Srivastava, Director CSIR MP Bhopal, has been identified by Stanford University among top 2% most cited scientists all across the world. Along with the deep knowledge on the fundamental sciences, he also has command on the technology development and has more than 20 patents in his credit and almost the same number of know-how technologies transferred to various industries. Among various facilities, one of the most important facility that has been established by Director CSIR and Bhopal is the transmission electron microscopy and electron energy loss spectroscopy that are very few across the country. He has been the fellow of number of organizations like IIM, EMSI, and so on. It's our great pleasure to mention that Professor Srivastava is the president of Electron Microscope Society of India as well. He has number of awards on his name. Few of them are Meteorologist of the Year Award by Ministry of Steel, INSA COSF Fellowship, Boyce Fellowship, and so on. Professor Srivastava is also serving in various committees of Ministry of Science and Technology, DST, etc. He has also worked as National Coordinator in Bureau of Indian Standard and has immensely contributed in his field. He has worldwide collaboration where he is closely associated with various institutes. Some of them are Argonne and Brookhaven National Laboratories of USA, Technical University Darmstadt, Germany, Department of Energy, Italy, and many more. The list is very long and for the achievement of Professor Srivastava, which is filled with uncountable number of such prominent works and titles and which are very difficult to share in this few lines. Now, not taking much of the time, I would like to invite Professor Abnesh Kumar Srivastava, Director CSIR MP Bhopal, for his welcome address in the opening remark to the August gathering. Sir, please.
Thank you, Dr. Sarika Verma. It's my pleasure to be part of this program, Azadi Ka Amrit Mahotsav and 80 years of CSIR. We know on 15th August 1947, India got independence, and this 15th August, we celebrated 75th independence of our country. Same time, Council of Scientific and Industrial Research got established on 26 September 1942. So it's a very rare and very amazing and very promising um, uh, point of time the country is that we are celebrating both Azadi Ka Amrit Mahotsav and 80 years of CSIR. We are fortunate to have with us today the chief guest of the program, Professor N.S. Raghuvanshi ji, Director Maulana Azad National Institute of Technology, Bhopal. Guests of honor, Dr. Piyush Dua from University of Technology and Applied Sciences, Oman. Professor Kishanu Basu, Materials Engineering Department, IIT Kanpur. Invited speaker, Dr. Rajni Verma from University of Melbourne. She is Mackenzie postdoc fellow there in Australia. Eminent speakers, Mr. P.S. Sardar, Deputy Commissioner, Navodaya Vidyalaya Sangathan, Bhopal region. Mr. Somesh Srivastava, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Bhopal region. Mr. Tajuddin Sheikh, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Jabalpur region. Mr. Vinod Kumar, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Raipur region. We also have school children of Kendriya Vidyalayas and Navodaya schools with us, faculties, parents, my own CSIR-AMPRI staff, and their family members, press and media. So I welcome you all on this very important occasion. This is also the time when we should see the kind of situation we are facing at present, that is COVID situation, where whole world is affected, and so our country too. And our Honorable Prime Minister and President of CSIR, Shri Narendra Modi ji, coined the term Atmanirbhar Bharat on 12th May 2020 in the context related to manufacturing and related business of PPE kits. It is also important to highlight the significance and importance of updates and upgradation of industrialization, which normally starts with Industry 1.0 in late 18th century with the introduction of power loom and steam engine. And then of late in 2010, we talk about Industry 4.0, which introduces the automation, data science, cloud computing, 3D printing, additive manufacturing. And now Industry 5.0 has also come to the step, saying that with the concept of man works alongside robots and smart machines. So the industrialization is very, very important aspect to make any country Atmanirbhar. And here we are talking in the context of Atmanirbhar Bharat, means the India should be self-reliant. It's a very important, and so our responsibility also goes up as a scientist, as academician, and all associated people. So as a whole fraternity, whoever is directly or indirectly associated with the university system, R&D system, and private sector, and wherever the growth is possible, whoever is associated directly or indirectly, it's our collective efforts, collective responsibility to make the country Atmanirbhar. It's a very good idea that this program is being organized by CSIR Advanced Materials and Process Research Institute, Bhopal. And at same time, the CSIR has also got responsibility to have this, to run Jigyasa program, which is important for school children to attract them to inculcate in young minds about science and technology, so that in future we have one of the best scientists of the world from our country. So this program is being organized jointly by CSIR-AMPRI and CSIR Jigyasa, being coordinated at AMPRI. I must thank all the guests eminent speakers, the school children, their faculties, their commissioners of the schools, their parents, my own CSIR-AMPRI family members, and who are all directly or indirectly involved in today's program, including press media, to celebrate this Azadi Ka Amrit Mahotsav and 80 years of CSIR all together today, hosted by CSIR-AMPRI Bhopal. In addition to that, I must say that the Indians sitting in across the globe, like we have three speakers, scientific speakers today, and they are educated, trained in India up to their PhD level, but they belong to three different countries. Professor Kishanu Basu from IIT Kanpur, India, Professor Piyush Dua, he is PhD from IIT Roorkee, he is in Oman University, and Dr. Rajni Verma, she is PhD from NPR New Delhi, and she is in University of Melbourne. So that also shows that wherever Indians are there, they are happy to celebrate and they are part of this Azadi Ka Amrit Mahotsav and 80 years of CSIR. With this brief note, I conclude my presentation, my views, and I wish all the best for this for the success of this today's program, Azadi Ka Amrit Mahotsav and 80 years of CSIR. Thank you. Dhanyavad.
Thank you, sir. Thank you for your kind remarks. Ladies and gentlemen, now to move ahead. It's our proud privilege that today we have with us a very eminent personality, Professor N.S. Raghuvanshi, Director, Maulana Azad National Institute of Technology, Bhopal, as a chief guest of this program. To invite him for his address, I like to share his brief achievement list. He holds the PhD from the University of California, Davis. He has more than 25 years of experience in the research and teaching various aspects of water management, information technology, applications in agriculture and climate change. He has developed several techniques and research tools and web-based course materials. He has made a significant contribution in the area of irrigation system performance, evapotranspiration, estimation techniques, hydrological modeling of the agricultural watersheds, and the development of educational and design softwares. He has published more than 110 papers in peer-reviewed journals and has completed several research projects and consultancies which has been funded by various national and international agencies. And also he has guided many PhD scholars as well. He is the recipient of various awards and fellowships. Some of them are Rotary International Fellowship, Fulbright Nehru Senior Research Fellowship, and many more. He is also the Fellow of Indian National Academy of Engineering and also a Fellow of the National Academy of Agricultural Science. It's not easy to put his words again to concise and to share the achievement. So now to move ahead, I am pleased to invite the chief guest of today's program, Professor N.S. Raghuvanshi, to kindly address the August gathering. Sir, please. Thank you.
Thank you very much. Dr. Avinash Srivastava, Director, AMPRI Bhopal, Professor Basu, Professor Dua, Professor Verma, Commissioners KBS, fellow scientists and staff members of AMPRI Bhopal and various CSIR institutes, teachers, school children, other guests, and ladies and gentlemen. Very good afternoon to all of you. And at outset, I'm thankful to Dr. Srivastava for inviting me as a chief guest for today's function on Azadi Ka Amrit Mahotsav and 80 years of CSIR and giving me an opportunity to be with you this afternoon. All of us are fortunate enough that we are born in independent India, and many of us really do not have an idea about the price paid by our forefathers to achieve this freedom, except learning few chapters in our school books. Millions of our countrymen fought the battle and sacrificed themselves to achieve freedom. In order to understand the value of freedom, we just have to see the recent events in our neighborhood, particularly in Afghanistan. Looking at the situation, we should be proud of our freedom and we pledge that we will protect our freedom at all cost. Azadi Ka Amrit Mahotsav is an initiative by Government of India to celebrate 75 years of freedom of progressive India and the glorious history of its people, culture, and achievements. The Honorable Prime Minister inaugurated the year-long celebrations from Gujarat on 12th March 2021, which also marks the 91st anniversary of the historic Salt Satyagraha led by Mahatma Gandhi. These celebrations will end on 15th August 2023. Prime Minister declared that the festival should encompass the glimpse of the pride of Sanatan Bharat and the glory of modern India. He said that it should reflect the light of the spirituality of sages, along with the highlighting the capabilities and strength of our scientists, depicting the magnificent journey of our nation. He further puts emphasis on creating a vision, India at 2047, social and cultural events showcasing the scientific accomplishment and technological advancement will be part of these celebrations. It will be an attempt to highlight contribution of not only known but also unacknowledged valiant freedom fighters. I feel that there is a need for scientific thinking for development and progress of the country. When we became independent 75 years ago, nobody gave us a chance and they thought that we will not be able to handle it. However, we have proved them wrong and we have done much better than many other countries that became independent at the same time. We are a frontline nation in various fields in the world, and a lot of credit for that goes to hard work and dedication of our scientific community. They have contributed enormously to India's rapid progress in the last 75 years. CSIR and other scientific organizations have played a significant role in India's progress. CSIR, an umbrella organization of many scientific research laboratories, and over the years contributed towards the development of technology in the areas of agriculture, environment, computing, health, transportation, housing, materials, to name a few, for betterment of the society, industry, and overall development of our country. We all know that CDEC has developed a supercomputer called Para. However, India's first parallel computer, flow solver, was built in 1986 by CSIR to overcome the challenges posed by the Western technology, which was either too expensive or denied. Flow solver success triggered the other successful parallel computing projects in the country, such as Para. These denial-driven innovations led Washington Post to remark, "And angry India does it." CSIR developed technology to produce baby food from the buffalo milk with excellent digestibility, and given this technology to Amul, and we all know that the Amul milk powder is based on the technology developed by the CSIR. Millions of our countrymen are suffering from the diabetes, and CSIR has developed Ayurvedic medicines for diabetes. Both Manet and CSIR-AMPRI, being the national level institute, have a unique group of outstanding young minds from all the states of India and union territories. Students from diverse backgrounds get to network with each other and get to identify and comprehend the wide spectrum of varied culture and regional practices in our country. The students here are not only given exposure to the latest technological advancement in their chosen field, but also trained to be responsible human beings. The enriched learning experience develops the student trigger mind, a series of activities which takes place along with the regular academics opens them to challenges of leadership of tomorrow. These institutes provide students enriching and life-defining experience that enables them to reach new heights in their professional and personal lives. The institutes have going on academic and research collaborations with many national and international institutes in order to keep the pace with increasing frontiers of knowledge. Since the past years, in order to synergize our R&D and academic activities in the field of mutual academic interest, CSIR-AMPRI Bhopal and MANIT has worked in collaborations for research and development in the areas of construction materials and technology and upscaling of developed processes. Further, we have been exchanging MTech and PhD scholars for their research and dissertation work. Besides this, AMPRI scientists have been members of Board of Studies of many departments of MANIT Bhopal. I appreciate the support given by AMPRI scientists for modifying the syllabus of some of PG courses to make it more effective and relevant to current societal and industrial applications. Our students are benefited from the vast experience of many retired scientists of AMPRI who comes from as visiting faculty to MANIT. Moving forward, MANIT aspires to create valuable repository of Indian traditional knowledge system through technology transfer activities with CSIR-AMPRI. MANIT strongly believes that inclusion of our Indian traditional knowledge system as one of the driving forces will facilitate the required strategic transformation and lead us on path of breaking new India as a vision by our Honorable Prime Minister, Shri Narendra Modi ji. So with this note, I conclude and urge you all to celebrate 75 years of India's independence with a pledge to build Atmanirbhar Bharat. Jai Hind, Jai Bharat.
Thank you, sir. Thank you so much for such an informative talk. Really, you've started with a very knowledgeable, detailed description about this special occasion that we are celebrating here, Azadi Ka Amrit Mahotsav. Then also you have talked about the contribution of CSIR towards this and how in each and every sector that CSIR is contributing for the overall development of our country. And also you have talked about a very special and a unique thing about the unique grouping of our CSIR-AMPRI as well as a MANIT, that how all the students, faculties, and everybody is getting benefited from all these activities that is helping the students in their personal as well as professional lives. So thank you once again, sir. Now to move ahead, we have a documentary movie on R&D work that is carrying out at CSIR-AMPRI Bhopal. And for that, I would like to invite and request my colleague from IT section, Shri R.S. Ahirwaji and Shri Narendra, to kindly screen the video, please. Thank you.
Imagine a nation making rapid strides like it has never been done before. From automotive industry that revolutionized the way Indians move, to launching record-breaking satellites by its aeronautics industry, weaving beautiful sassy clothes with fiber extracted from Sissel plants, goes through a sea change for a better India. Imagine a nation making rapid strides like it has never been done before. From automotive industry that revolutionized the way Indians move, to launching record-breaking satellites by its aeronautics industry, weaving beautiful sassy clothes with fiber extracted from Sissel plants, to developing buildings materials from waste, enabling affordable and safe drinking water, to paving strongest roads ever known to mankind. Everything that you need goes through a sea change for a better India. Welcome to AMPRI, opening gates to immense possibilities. In India, the hub for developing advanced materials is the Advanced Materials and Processes Research Institute, a flagship of CSIR's Essential Sciences. Located in Bhopal, Madhya Pradesh, this unique institute is a proud possession of India. For there are such very few niche institutions working on metallic foams worldwide. AMPRI Bhopal was established in 1981 as Regional Research Laboratory that started functioning from CSIR, its parent body at New Delhi. With its rapid expansion, it relocated to Bhopal in 1983. Serving crucial needs of Indian defense and industries, AMPRI is engaged in R&D on materials and processing, with special focus on synthesis, characterization, and processing of different materials. Especially advanced materials like lightweight aluminium matrix composites, carbon foams, aluminium and magnesium alloys, with an aim to substitute heavy materials and to achieve special properties for special use. AMPRI is well equipped with high-tech machines that are needed for material characterization, especially for metallic, ceramic and polymer materials used in the engineering sector. The optical microscope, interfaced with image analyzers for quantitative metallography, is world-class. Here, grain size distribution of volume and fractions of phases, grain boundary and particle size can be precisely quantified. The two scanning electron microscopy machines produce images of a sample by scanning the surface with a focused beam of electrons. The FESEM, or Field Emission Scanning Electron Microscope, with better resolution can scan to nanometric level. Attached with EBSD, electron backscatter diffraction, a microstructural crystallographic characterization technique, it helps in understanding the structure, crystal orientation, and phase of materials in the scanning electron microscope. There are two XRD machines. The high-tech apparatus produces an interface effect and diffraction pattern that helps in providing accurate information on the structure of the crystal and also reveal the identity of a crystalline substance. The MiniFlex benchtop X-ray diffractometer machine is also capable of residual stress and texture analysis in addition to the phase analysis, while the optical microscope is capable of analysis in higher temperatures too. The micro hardness tester is an optical method where the size of indentation is measured. The depth of indentation caused is measured in the depth measurement methods. The larger the indent, the softer the tested material. The planetary ball mill with 4-ball grinding jars rotates, making the jar's axis rotate in opposite directions, leading to grinding and mixing of samples in high-speed movement. The apparatus is used for smashing and blending various products of different materials. The universal testing machine being displayed to the PhD students is capable of any type of mechanical testing like tensile, compression, bending, fatigue and fracture. These tests are possible in high temperatures as well as in cryogenic temperature. Amongst its various important laboratories is also Microfluidics and MEMS Center to develop and characterize the lab-on-a-chip device or micro-total analytical system and their application for single molecule analysis in clinical diagnostics and environmental analysis. The primary aim of the center is to establish a center of excellence in micro-scale analytical separation technique and micro-reaction technology. The developed lab-on-a-chip technique requires only very small quantities of the sample for analysis and has relatively short analysis time, making the technique more economical.
At present, in CSIR-AMPRI Bhopal, we are having 6 R&D divisions in the name of lightweight metallic materials, smart and functional materials, integrated approach for design and product development, radiation shielding materials and cement-free concrete materials, water resources management and rural technologies, and advanced construction materials. We are trying to have export quality technologies. I can differentiate here technologies which is useful for the country and the technologies where we can compete internationally. The patents which we are developing, we are filing in India and abroad. They are again internationally reputed patents. And then the publications which we are having, they are in international journals.
The products being developed here are for the engineering sector. The area still evolving is the thermo-responsive materials, where deformation can be induced and recovered through temperature changes. The shape memory alloys, when correctly harnessed, can become a lightweight, solid-state alternative to conventional actuators and sensors. Designing and developing copper-based shape memory alloys has been CSIR-AMPRI's thrust area of research since a few years now. The aim is to develop low-cost, effective and better performing metallic shape memory alloys which can replace components for automobile and general engineering sectors. CSIR-AMPRI has successfully developed complete set of compositions with different alloy systems including copper aluminium nickel, copper aluminium magnesium and copper zinc aluminium, with different alloying additions and grain refiners which exhibit shape memory properties and high transformation temperatures over 250 degrees centigrade. The most used amongst all shape memory alloys is the nickel titanium alloys, commonly known as nitinol. After mixing fine elemental powders for 8 to 10 hours, cold compaction is followed by sintering. The powder metallurgy route eliminates the defects of liquid metallurgy route, like large grains and high elastic anisotropy, leading to enhanced brittleness of the material. The sintered material is then heat treated at 7 hours in order to homogenize the austenite phase followed by quenching. Latches in automobiles use this function of actuation to control various functions of the car, as well as providing comfort and safety to the driver. Any automobile incorporates numerous special purpose latches, such as components of doors, hood or bonnet, truck or boot door, and the petrol tank lid, etc. Presently, most of latches are mechanically operated either by applying tension through cable wire or by electromechanical means, which is activated by DC motor or by solenoids. this is an alternative approach for activating the latches. CSIR-AMPRI's latching actuator devices for automobiles has negligible mechanical parts comprising of only shape memory alloy elements, mechanical force transmitting lever in circular and/or rectangular cross-section and pulleys, making it an effective way to reduce weight and minimize complexity in actuator design and control. In the aeronautics industry, every matter counts, for each element etched in it adds to the combined weight affecting its fuel efficiency. Finding replacement for nuts and bolts without changing the composition of an element is perhaps a challenge not many have forayed into. The magnetic pulse welding machine can easily join metallic sheet and tubes. The high-velocity electromagnetic and electrohydraulic forming process discharge energy from capacitor banks, improving formability of material and controlling spring back and wrinkling. A concern for design engineer while using lightweight materials. This 40 kilojoule electromagnetic manufacturing machine can produce current of the order of 300 kiloamperes at frequency of 10 to 15 kilohertz. Presently, AMPRI Bhopal is working on joining dissimilar metals of various combination like copper to stainless steel, titanium to stainless steel, and niobium to stainless steel. Designing and development of aluminium metal matrix composites has been a thrust area of research in CSIR-AMPRI since its inception. AMPRI is well recognized for this aluminium matrix composite not only in India but also in international level. The aim has been to disperse uniformly the reinforcing agent in the aluminium alloys for improvement in strength and stiffness. The aluminium alloy is prepared within a furnace. The melt temperature is maintained continuously. After cleaning the melt, the preheated reinforcing particles are slowly added into the melt chamber kept inside the furnace. Simultaneously, the melt is stirred using the attached stirrer over the furnace. During stirring, a buffer plate is used to destabilize the laminar metal flow within the vortex and provide more shearing action for better distribution. These composite materials can replace a large number of steel and cast iron components. AMPRI Bhopal is also actively engaged in process development for making closed cell aluminium and zinc foams through liquid metallurgy process. It is the only laboratory which has established facilities and expertise to make large quantity of closed cell aluminium and zinc foams. In fact, AMPRI is able to make these foams at much competitive cost as compared to the international market. In case of closed cell metal foam, the metallic body contains more than 50% of porosity in cellular form. Because of the porosity, the density of foam is very low. It may vary from 0.2 gram per cubic centimeter to 1 gram per cubic centimeter. These foams thus can be used as bouncy products like life-saving boats, shipbuilding, multi-layer sandwich panels, sound and vibration attenuation. Also, an excellent material for blast and impact energy resistance. Space, defense, railways and automobile sectors are in close touch with CSIR-AMPRI for this material development. The technology of synthesis of aluminium alloy-based silicon carbide particle dispersed composite has been transferred to Exclusive Magnesium Private Limited. These scientists are working to develop advanced non-toxic materials in the area of radiation shielding and cement-free concrete materials. red mud is a solid alumina industrial waste which is rich in iron oxide, titanium oxide and other heavy elements suitable for attenuating high-energy photons like X-rays and gamma rays. CSIR-AMPRI is the first in India to demonstrate ferrous-rich red mud that can be used to fabricate radiation shielding tiles for X-ray attenuation. Prepared by mixing barium sulfate and binder with the red mud, it is sintered at 900 degrees centigrade. The 6 mm red mud tile possesses the attenuation characteristics equivalent to 0.9 mm lead. This material was accredited by Atomic Energy Regulatory Board. The technology has been transferred to Ashores, Noida, who have undertaken a crucial assignment of covering the entire CT scan and X-ray diagnosis rooms of Sai Deep Healthcare Private Limited, Ahmednagar, Maharashtra. CSIR-AMPRI scientists are actively working on increasing the density of the tiles further to improve its attenuation characteristics and thereby to widen its application in nuclear power plants and food irradiation center. Following the mantra of waste to wealth, AMPRI Bhopal has successfully created high-strength composites, sandwich composites and hybrid composites with glossy finish. Converting the industrial waste, especially from the marbles, AMPRI Bhopal can make tiles, doors and even rooftops. The waste material is used as the raw material and added with fiber for giving it the much-needed strength. And then polymer is used for binding the treated raw material and the fiber. As a basic step, the raw material is grinded, sieved and put in oven. The fiber is treated through chemicals for fire resistance. And the polymer is mixed and made into liquid. After which they are put together and pressurized. The use of certain material and manufacturing also makes it free from insects, fungus and termite and corrosion attack. Hybrid composites are 4 times stronger and 30% cheaper than teak wood. Compared to synthetic wood in the same price, hybrid composites are 7 times better in quality. Hybrid composites are self-extinguishable, durable and corrosion resistant and has very high strength to weight ratio. Lab-scale experiments for manufacturing waste particulates are also available at AMPRI before put to production at the workshop. The technology of hybrid wood substitute composites has been transferred to VSM Industries Private Limited. The technology of high-performance hybrid composite material has been transferred to Siddhi Poly Matrix, erstwhile Chauhan Fly Ash Products Limited. The technology of advanced hybrid composite wood and wood substitute has been transferred to Eco Bright Sheet Private Limited. Sissel plant produces the hardest vegetable fiber with many applications in clothing and handicrafts. The yarn in textile made out of this fiber is used for making composites for applications in many sectors. During the 11th 5-year plan, the Institute has taken up a project under rural sector projects called Sissel Fiber Technologies for Rural Employment Generation. This technology is transferred to Panchayats and Rural Development Department Government of West Bengal. CSIR-AMPRI has also developed Sissel buffing wheels that can replace cotton buffing wheels generally used in the industrial units for polishing, buffing and stripping and stain removal. Sissel is made into thin sheets and then compressed to make into layers. It is then contained in suitable form like felt and cotton cloths. The product is made from natural material. Compared to cotton buffing wheel, the manufacturing time and cost would reduce by 30%. Unlike its counterpart, it doesn't need glass fibers. The buffing time reduces by 15 to 20%. The product can be used in rural metal handicraft industry, engineering, automobiles and furniture. The demand for concrete as a construction material is increasing, and also is the demand for Portland cement. The process of production of Portland cement is energy intensive, consumes large quantities of non-replenishable natural resources such as limestone. It is also responsible for global warming with the emission of carbon dioxide. CSIR-AMPRI Bhopal has invented geopolymer-based cement-free materials to address these concerns. The synthesis of aluminosilicate occurs at a minimum temperature of 35 degrees centigrade. This helps in reduced energy consumption and produces about 80% less carbon dioxide emission in comparison to cement. It also eliminates the need for non-replenishable raw materials and is based on aluminosilicate raw materials like fly ash and industrial waste generated from thermal power plants. CSIR-AMPRI Bhopal has developed a process and design mix of solid foam, fly ash-based geopolymeric concrete utilizing fly ash and dry alkaline activators, aggregates and water. This pavement road has been made from solid foam fly ash-based geopolymeric concrete. When dissected, one can see multiple layers with high strength, excellent volume stability and better durability. The cement-free concrete technology has been transferred to Jindal Steel and Power, Raigad. AMPRI Bhopal has developed advanced geopolymeric coating material utilizing fly ash and other additives to coat mild steel plates. Its efficiency was found to be about 85% and corrosion rate 2 to 3 times lower than uncoated mild steel.
Preview.
For the first time in India, CSIR-AMPRI Bhopal has made an attempt for utilization of silo fly ash along with sea sand and sea water for developing advanced geopolymeric concrete material as a new material for broad application spectrum. In this area of research, a patent has already been filed by CSIR-AMPRI Bhopal in India, USA and UAE. Seawater cannot be used for conventional cement concrete as it has high chloride content, which creates honeycombing of structures and leads to corrosion of reinforcement bars in cement concrete. It has therefore become necessary to look for an economically and technically viable option wherein the fine aggregates can be suitably replaced with sea sand available in large quantities in our country, and its limitations can be used to full advantage in making new material. That is, advanced geopolymeric concrete material for non-structural applications. After testing and leaching for toxic elements for chemical analysis of fly ash with the zero headspace extractor, CSIR-AMPRI has successfully made mortar cubes, concrete cubes, beams, paver blocks, and sea sand seawater based geopolymeric tetrapods. The advanced geopolymeric tetrapod made from this new material, developed by CSIR-AMPRI Bhopal, shall serve as seashore barricading for coastal erosion. It can also be used for prevention of canal bed scouring and river bank protection, and can be used as breakwaters to protect anchorage from the effect of weather and as a filling material. Geopolymers are a new generation of material with diverse applications in the building industry and waste management. This technology has been transferred to Hindustan Copper Limited, Malanjkhand, Madhya Pradesh. Long-term consumption of water containing excessive fluoride causes serious health problems with even crippling of bones. CSIR-AMPRI has developed low-cost nano-adsorbent-based domestic filter device to help India for the first time drink completely safe water. The synthesized nano-adsorbent is of very low cost and porous in nature that can remove 20 to 25 mg per gram of fluoride and 25 to 30 mg per gram of arsenic at neutral pH. The developed filter modem can filtrate water at 5 to 10 litre per hour filtration rate without leaching of incorporated nano-adsorbents. The treated water is free from any secondary contamination and retains all essential minerals and provides safe drinking water as per Indian standards. The nano-adsorbent is made through precipitation reaction, after which it is dried and heated and then ground to make it in powder form. The water purifier does not require electricity as it is made through filtration. It removes arsenic, fluoride, chromium and microorganisms and is user-friendly. Unlike RO, which wastes 45 to 60% of water, this filter wastes none, thus making a safer and healthier India. This technology has been transferred to Social Enterprise Private Limited.
We have taken the research projects under those theme areas. Some of them are metals, mining, minerals and materials like aerospace, agriculture, nutrition, biotechnology. Some of them, these are water, environmental science. So we have undertaken the projects. And while doing the research, we try to translate those research findings and we develop the technology. And almost all the technologies developed by CSIR labs, they are supported by intellectual property rights. We file patents for the country, we file patents for abroad also. So they filing the patent and having the intellectual rights give us the edge for marketing through our industrial partners.
Bamboo is the world's fastest growing woody plant, which grows 3 times faster than most other species. So far, its use is limited to foundation or supporting posts in houses. Appropriate polymer coatings or treatments and surface covers are needed to enhance the useful life of bamboo. The development of standard regular shapes of bamboo polymer composites would provide opportunity to use bamboo at large scale with high potential for construction industry. The lignocellulosic natural fiber is used as reinforcement in polymer matrix composites. They can easily replace commercial materials like laminates and boards. CSIR-AMPRI is developing smart materials that have one or more properties that can be dramatically altered at a particular situation. These materials have the capability to sense their environment, process this data and respond. This will solve engineering problems with unachievable efficiency. With metals and polymers, AMPRI is also developing thermosensitive smart materials having faster responses. The injection molding machine provides the precise time, temperature, pressure, environment, and composition controls. This carbon nanotube reinforced shape memory polymer responses much faster than conventional polyurethane. Assessing groundwater potential on both quantitative and qualitative basis requires an understanding of complex interplay of various parameters that dictate the utilization pattern and the basic processes that govern the water resource potential. CSIR-AMPRI carries out satellite and computer-aided studies in integrated water resources management. The interpretation of groundwater level requires researchers to go on the field with sophisticated machines guided by the satellite. Samples are also collected. The soil analysis helps the scientist by finding out the moisture level of the soil. This machine heats up the sample, so the moisture evaporates, and then the sample is weighed again to find out the difference. The water sample collected is also analyzed in order to understand its composition. AMPRI Bhopal has a permanent GPS installed for sampling a water table. All this aids in flood forecasting and flood management, decision support system for watershed management and remote sensing, GIS and GPS surveys. The computer simulation and modeling section does just that. The simulation is utilized in material deformation behavior assessment, optimizing various manufacturing processes like bulk and sheet metal forming and pressure die casting process, design of components, life prediction of piping component, failure investigation, and fatigue and fracture assessment of materials and components. AMPRI had also carried out simulation works in projects given by General Motors, Tata Motors, BHEL, BARC, IGCAR, BRNS, and DST, besides many more. Graphene has attracted a great interest because of its unique band structure and electronic properties that makes it promising candidate for next generation electronic device and multifunctional composites. AMPRI Bhopal has already demonstrated high quality single layer graphene on copper foils. The graphene grown here are of very high quality and ratio of intensity of 2D peak and G peak is almost 4. The laser additive manufacturing undertaken by AMPRI is one of the advanced technologies capable of manufacturing complex engineering components with superior material properties by layer deposition of material directly from CAD model. All this has been achieved because of CSIR-AMPRI's firm belief that waste to wealth is the key to India's development. Understanding and involvement to the directorial level ensures that the lab's requirements are smoothly taken care of. Besides inventing and innovating for nation development, AMPRI Bhopal also has many programs to disseminate their knowledge to the young and researchers alike. As a part of Jigyasa program, students from Kendriya Vidyalaya are called to interact with scientists and are given live demos as an extension to their learning. Sophisticated Analytical Instrument Facility, SAIF, aims to provide high-quality analytical services to researchers. It gives the research students hands-on experience with high-end machines and provides a live simulation to the real world. AMPRI keeps a very high standard when it comes to learning from the cream of academia. The Academy of Scientific and Innovative Research, or ACSIR, assists students with the theoretical knowledge. Students with high academic performance are selected after an open interview, and only candidates with fellowship are admitted. Industry-sponsored candidates are also invited. It is not just science for AMPRI. At the heart of it, AMPRI strives to provide its staff the world that is safe and promotes growth. The warm approach of the staff is probably what drives AMPRI and leads it to its success. The library stacks numerous books for research and publications that keeps scientists and scholars abreast with the latest technologies. Beside the residential complexes, there are green, luscious parks where the children can play within the campus and for the older, there are many recreational activities where they can rejuvenate. The residential complexes are also attached to a clinic. The guest house and the canteen are open to all within the campus, including the planning and performance division. An ecosystem within itself, and yet with keen eye to achieve the best. AMPRI Bhopal is certainly the crown jewel of CSIR.
Thank you. Thank you for this such a wonderful movie. Ladies and gentlemen, I am sure you would have enjoyed this movie and you would have got the glimpse of whatever work we are doing here in the AMPRI. It starts from the basic research R&D, then it goes in the form of papers and patents are there. Then we are developing this pilot scale facilities, demonstration lab to land is also we are involved in, and then transferring the technology to various industries, and so that then it can go to the society. So we have a complete package of the excellent expertise, and also you would have seen that we are working in the various areas wherein we are helpful for the society. It is not only the work that we are doing over here, but the dissemination of the knowledge and the dissemination of the work we are doing, we are sharing it with the school student, college students in the form of a Jigyasa program, in the skill development program as well. We are also involved in ACSIR and all other activities. So now, thank you once again. Now to proceed further, we are very grateful to have with us a very, very special guest with us, Dr. Piyush Dua, keynote speaker of today's program, professor from University of Technology and Applied Sciences, Suhar, Oman. I am very glad to share with you that he is physically present here in our campus CSIR-AMPRI Bhopal to celebrate this special occasion of 75th year of independence as the Azadi Ka Amrit Mahotsav and 80th year of CSIR. Thank you once again, Dr. Dua. for your kind welcome again, and thank you to visit to the AMPRI campus. Now, have your lecture, before that, I'd like to introduce you with the audience. Dr. Dua has obtained his PhD degree from Indian Institute of Technology, Roorkee, India. After finishing his doctorate, he had served in various institutions such as University of Petroleum and Energy Studies, Dehradun, MITS, Amity University, Noida, etc. He has also worked as postdoctoral scientist at Pohang University of Science and Technology, Pohang, Korea. He has more than 15 years of research and teaching experience. He has been awardee of various projects which has been sponsored by BRNS, AICT, etc. And he has published more than 2 dozen of papers in referred journals of international repute, which includes the Journal of Biomedical Nanotechnology, etc. He has been an awardee of various awards and have very much credential in his credit, like he was selected in the category A speaker by Department of Science and Technology, Government of India in Theoretical Physics Seminar Circuit. Recently, he has got the Asia Award from Blackboard Company for Innovation and Excellence in the Blackboard Global Community for Practice for Faculty Development Program. So once again, I welcome you, Professor Dua, and I would invite you for his very special talk, that is Computational Material Science Future Perspective. Professor Dua, please. Thank you.
Thank you, Dr. Sarika, for a nice introduction. Today's chief guest, Professor N.S. Raghuvanshi, the director from Manit Bhopal, director of AMPRI Bhopal, Dr. Abnesh Kumar Srivastava, all speakers from the different parts of the world, the officials from the Kendriya Vidyalaya Sangathan and Navodaya Vidyalaya, and students along with their teachers, parents, and principals. It is indeed a pleasure for me to be a part of this program, which is being organized by CSIR, and this whole country is contributing and celebrating this event of 75th Independence Day, which is going to be held in next year, but the celebrations are already started. Along with that, the scientific community is having one more reason for celebrating, that is the 80 years of CSIR. So being a part of this event, I'm really happy and would like to thank Dr. Avnish Kumar Srivastava for inviting me and giving this opportunity to be a part of this event. And especially, it becomes very special when I'm here at the campus to celebrate this event. So with this, let me start my presentation. I hope is it visible? The presentation is visible?
No,
No, not yet, sir.
Okay. I hope is it is visible now.
Now it is visible, sir.
Okay, thank you. So the title of my talk is the Computational Material Science Future Perspective and the role of memristors for the future of robotics, artificial intelligence, and the brain-like computing. For the students, let me give you a brief introduction about the computational material science. The computational material science studies the interaction between or among the atoms and molecules of the different systems to explore various properties, such as, first of all, whether the material is an insulator or a semiconductor or a metal. Beyond that, what are the optical properties, electronic properties, and thermal properties. For that, we take the initial structure of any material And then we go with the computational models, which has been developed by various organizations and various groups around the globe. And then we do the optimization and the simulations. The structures differ because of their atomic arrangements. For example, if we take the carbon, we know that graphite is being used in a pencil and the cost is very low, that everybody in his or her life can use very easily this graphite. At the same time, diamond is having all carbon, but it is very expensive. Even there are so many people, those who do not have the chance to see a diamond in front of the eyes. The another carbon-rich material is graphene, which is being used as the material for various applications. So all these three materials are having specifically carbon, but they are having their atomic arrangement differently. And that's why we need to have the atomic structure for getting the information about whether the material is having insulation, whether the material is having the insulator properties or semiconductor properties or metallic properties. Apart from these three, we can have various allotropes of carbon. So to get the information about different allotropes, we use the computational material science to get the information about their properties. For my work, I'm going to give you a very small introduction, what we have done using the low dimensional systems. From low dimensional systems, the meaning is where we are using the materials which are in nanometer range. A nanomaterial which is having the dimensions less than 100 nanometer materials is used, and for our purpose we have used specifically the 1D nanowires of transition elements to find out the magnetic properties and conducting properties, that how this magnetic properties and conducting properties can be used all together for the device purpose. In these low dimensional systems, when we go for the magnetic properties, we can see that the density of states of downspin electrons are getting different on getting the magnetism. In the beginning, you can see this is a non-magnetic system where the density of states are same. It means it has both upspin and downspin electrons, which are same in numbers or density. As the density changes, the magnetic state comes into the picture. And when we have low dimensional systems, there are so many materials which are not having the magnetic properties in their bulk state. But when we make the one-dimensional material or two-dimensional material, they show magnetic properties. So in our case, we have used some systems which are having one-dimensional or two-dimensional structures, and they are specifically being used for the spintronics and Memristor based devices. To start with, this is the structure of a nanowire, 1D nanowire, or we can say that ideal nanowire, which is simulated, and the sheet if we have a two-dimensional material. Using this basic structure, we go for the computational models and to find out the properties, that how this system behaves once it is synthesized. So one of the properties which I'm going to explain is called the density of states. In these results, we have various systems. Few systems on the left-hand side are having the less than half filled band means the D band is less than half filled, and on the right side we have systems which are having their D band which is more than half filled. So in these systems, we can see that this line is making a difference between upspin density of states and downspin density of states. So for these systems, we know that few systems which are not magnetic in their bulk state, but all of them, they show the magnetic properties in their nano level arrangements. In the left side, we can see that the upspin density of states are having more contribution than the downspin density of states. It means that the upspin electrons are creating their presence on the Fermi energy. This dashed line is showing the Fermi energy. Below this Fermi energy, this side, left-hand side, is representing the valence band, and the right-hand side is representing the conduction band. So these upspin electrons are contributing in conduction, as well as when we have the density of states which are differently occupied for upspin and downspin electrons, it shows that system is showing the magnetic properties. On the right hand side, we can see that the upspin electrons are situated well below the Fermi energy. It means they are not contributing in the conduction, but the downspin electrons are contributing at the Fermi energy. It means they are contributing in conduction, and upspin electrons are contributing in the maintaining the magnetic state of the system. So in this way, we can very easily get the information about the system, that how the magnetic properties are coming when we synthesize or make the material through different processes, and how their conducting properties will behave once they are being utilized as a material for any specific device. So as far as computational material science is concerned, I have shown one of the properties which we can get information about. There are some other properties also available which we can simulate through computational material science based software or packages. I'm not going into the details of those, but just to give you some keywords, that finite element methods can be used on macro scale, and density functional theory and molecular dynamics are the tools which we can use at the micro level scale. I have used density functional theory for showing these results. And also the high performance computing architecture was used for such purpose, because the calculations or simulations are very time consuming and we require very high level of accuracy. So that's why we use the high performance computing architecture, on which we can have a lot of processing nodes which can perform the calculations for a single problem with a high level of accuracy and to save the time. A large number of electronic components are installed on a computer chip for the purpose that everybody knows. Now I'm going to share that how this era of computing is going to be changed. The number of components, as I was talking in the last slide, is having n number of components, mainly the transistors, which can be installed on a chip. The growth of the number of transistors is known to almost, I think, everyone, that initially it was very big, and as the time passed, in 1960 there was Moore's law, which was given by the founder of Intel, that the number of transistors can be doubled on a chip, and the industry followed the trend. And now we are in the zone where we can say that the Moore's law is going to be saturated, and that has been told by various technocrats that beyond this, Moore's law is not going to be continued. It means the size of the components which are getting smaller and smaller is coming to a stage where the size of the components cannot go beyond that limit. So in that case, the question is whether the development will stop as far as the number of components which are going to be smaller and smaller, and the size of the components will be saturated or not. As we can see that we have already got processor at 10 nanometers and the processing chip at 5 nanometers. It means if we have a silicon, we have just 30 to 40 silicon atoms proposed in a line, and that will cover just 5 nanometer chip. If it is a spherical, then we'll have some few hundred silicon atoms. It means we need to go for the quantum mechanical simulations for the purpose to get the information about the systems, because we are dealing with the atoms and molecules which are having very small dimensions. Now, as far as the future perspective is concerned, that is going beyond Moore's law, we need to have multifunctional devices. For the multifunctional devices, we need to have a material or device which can have electronic properties and magnetic properties, both which can be controlled through different inputs. So we know that the electronic circuit theory uses the resistor, capacitor, and inductor. Now, the fourth has been added in the list, which is having a name called Memristor. And that's what I would like to share with the students, especially that now we have one more passive element which has been added into the list somewhere about 12 years ago. I'll show you the details. So as far as any device is concerned, it runs on the 4 parameters called current, voltage, charge, and magnetic flux. For these variables, we have resistors to relate current to voltage, capacitors to relate voltage to charge, and inductors to relate current to magnetic flux. And we have 2 physical laws. But there was a missing component which can relate charge to magnetic flux. And here the role of Memristor comes into the picture, which can relate the charge and magnetic flux. So to understand the relationship, we have VI relationship represented through R. We have C to have the relationship between V and Q. We have inductor. We have 2 more laws, but this particular combination does not have any physical law or any process or any physical component which can relate charge and flux. So from the mathematical point of view also, we can have 6 mathematical relationship if we have 4 quantities. 5 are known. The missing link can be completed by the introduction of word called Memristor, which can have the relationship between phi and q, that is the flux and the charge. So that's what we have. Now, what is the importance of the Memristor in the technology as far as computing is concerned? That's what we need to understand. Before that, how this memristor can contribute in this technology, that has to be understood. So if we have the IV characteristics of a memristor, it shows a cusp. We have IV characteristics and we are having a cusp which shows a closed loop. And wherever we have a closed loop, it shows that there is chances of memory. So we are talking about the conducting properties through current and voltage graph, but we are also having memory intact. It means that this memristor can serve the multifunctional purpose with having conduction as well as the memory into it. In practical terms, the memristor performs similarly to a resistor, but it is able to alter its resistance to the amount and the direction of voltage applied. The important part where the memristor can contribute whenever we have no power means when we switch off a memristor, then it can remember its last stage. It means it can have memory intact whenever it is switched off. After getting switched off, when we switch it on again, then it comes with the same information which was stored before switching it off. Same way our mind works. Whenever we sleep, the mind goes somehow in hibernation stage. But when we got up after sleeping, we remember all our facts and all the things which were stored in our mind. So the functioning of mind is somehow same, which is being represented by the functioning of memristor. And that's why the memristor is being utilized as a particular material which can perform the task very much similar to the human mind. So as far as the getting information about memristor is concerned, why was it missing? Because all the four quantities were known and the relationships, only 5 were known. It was missing because the memristance is inversely proportional to the dimension square. Whenever we have a low dimensional system, then the amount of memristance which can be found out in that particular system would increase with the help of this relationship, which is the memristance is inversely proportional to the dimension square. Professor Leon Chua from University of California, Berkeley in 1971 gave the concept through all mathematical relationships. And in 2008, HP came with the physical working memristor model where they have used the titanium dioxide with some oxygen vacancies. So the concept was given in 1971 and the physical working model was proposed through HP, and that was also accidentally in 2008. Is it technologically important? I'll show you one of the application of the memristor. It has enormous applications. It is interesting for scientists because the memristor can have more properties or functional properties, multifunctional properties in comparison to the materials which can have a single property at a single time. It is also interested for the engineers because it can directly to be integrated in the devices and it can change the behavior of a device. And for the technocrats, it is important because the Moore's law is going to be saturated. They want to get the things to be moved on. For that, they need a material which can have the multifunctional characteristics. And HP has already started giving the products into the market. And there are other big giants also which have already contributed for the launching of Memristor-based devices into the market. As I was talking about, the Memristor can work like a human mind. For that, we need a Memristor along with the synapses, because whenever we need a biological memory, we need the communication between the neurons so that the information can be passed on from one part of the mind to the other part of the mind for the processing of the information. That processing of the information should become very fast, because the processing should go into the mind to get the output at a very fast rate. So for students, it is interesting because the next era of the computing is going to be changed, and that will require the multifunctional components or devices. It can be used in robotics. It can be used for memoristic minds. It can be used in artificial intelligence. And based on all these contributions, the future of Memristor are very bright. So as far as the brain is concerned, we have a network of neurons which are having very high number, 10 raised to power 11, and the synapses which connect the neurons to make the network are in numbers with 10 raised to power 15. So with this very huge network of our mind, we can do a lot of multitasking. We can remember a lot of information, and that particular characteristic is required in the computer systems as well. For that, the name is called Neuromorphic Computing. And Neuromorphic Computing is getting utilized through the contribution of Memristor. The reason is that we need a particular system where the processing of the information as well as the memory should be at the same place. Our brain, when it works, is having the processing as well as the memory at the same physical space of the mind. Wherever in the normal computer systems, this functioning of the processing as well as memory is separated out, and that requires long computational time as well as the large number of components to get the information from the computing nodes. And that's why the computational material science and other areas where we need very fast processing of the information, for example, data science, as well as the weather prediction models, they need very fast processing along with the less consumption of power. So as I was telling that in traditional systems, memory and processing units are separated, and it is having a process called, or the condition called, Newman block. To overcome the separation, we need functioning devices which can have the memory and processing unit at the same location. And such nano devices are multifunctional. At the same time, they are energy efficient, and the size of the components is very small so that it can have a large number of components to be installed on a small chip. It means the size would not be a problem when we are going to use these multifunctional devices. So from the information which I have shared, that this particular property where we have a cusp along with the current voltage graph, it shows the memristive behavior. So a big list of materials have been proposed which can have the memristive properties, and along with this, people are also searching more materials with less expensive devices which can have a low power consumption and the high performance as far as the time consumption of the processing is concerned. So to have the remarks from the current situation, that traditional ways to doing computing is going to be changed. The new era of computing is taking its shape. A lot of improvisations would be introduced in near future. And as far as the students are concerned, they should know that this change of direction requires a new element which has been proposed 12 years back called Memristor. And along with that Memristor, neuromorphic computing is taking a new shape. Recently, the problem of COVID-19 have been simulated using the computing resources from the IBM, and that was the quantum computers which has been built by IBM, and these results were much better in comparison to the classical computers in terms of the time consumption as well as in terms of the accuracy. And that's why the vaccine of COVID-19 has come in a very short span of time, which has served the purpose for saving the life for the particular from this particular situation. So with this, let me finish my first part of the presentation, and now I'm going to give a small introduction about the relationships between India and Sultanate of Oman, as I'm working presently in Sultanate of Oman. The Sultanate of Oman is a strategic partner of India. Sultanate of Oman is also a part of GCC, and it has also relationship with Indian Ocean Rim Association. The geography, history, and culture is very much similar for India and Oman. As far as the relationship, human relationship is concerned, it is very long, and the diplomatic relationships were established in 1955, and they were upgraded in 2008. The relationship went on when our Prime Minister Sri Narendra Modi ji visited Oman in 2018. A warm welcome was given from all the Indian community when he was addressing in a stadium to share the information which India and Oman are sharing as far as their business and their culture is concerned. Recently, Dr. S. Jaishankar ji has also visited Oman for different purposes. Visit of Omani dignitaries was also taking place time to time. In October 2018, a delegation of Omani officials visited India for the purpose of the event for renewable energy and experts meeting. Another glimpse of visiting Omani officials to India. As far as the scientific collaborations are concerned between India and Oman, recently Ministry of External Affairs has launched India League of Arab States Education Fund with a fund of 1 million USD, for which various projects have been proposed between the Indian science community and the science community of Sultanate of Oman. From our university, we have proposed two projects for water desalination, a domestic unit, and also for the hydrogen generation, because for the Vision 2040, the Oman has taken hydrogen generation on the first preference, because Oman is having very good quantity of sunlight and the natural resource in terms of water. So that's why, in addition to the petroleum, Oman is also going to focus on hydrogen energy, as well as the renewable energy in terms of the solar energy, for which the human resource pool is having a common goal. As far as India is concerned, India is also going to get the independent energy in terms of hydrogen. In addition to the relationship in terms of science, the educational exchanges are also taking place between India and Oman. A lot of students from India are visiting Oman for various projects, as well as a lot of students from Oman are also taking their higher education in India. As far as the sports are concerned, a lot of events are also being organized between the two countries. And recently, you will see a part of the T20 World Cup, which is going to be organized in Oman in the month of October, November. So with this, I come to the end of my talk. Once again, I would like to thank the organizers for giving me this opportunity to contribute in Azadi Mahotsav, as well as the 80 years of CSIR. I'll be very happy to have any comments or queries.
Thank you so much, Dr. Dua. It was really a nice presentation. Sir, can you unshare your slides now?
Pardon me?
Can you unshare your slides now?
I cannot get. Yes.
Okay, really. Thank you once again, Dr. Dua. It was really a very knowledgeable presentation, a very unique title that you have chosen. You have talked in detail about the computational material science and discussed about different properties. You started with talked about the fine element. You talked about the density function theory, and you have talked about other things as well. And you have talked about how the area of computing is to be changed and how the saturation of Moore's law is being stated by the technocrats. And then you have shared the importance of memoristics and how these memoristic based neuromorphic compounds are being useful for the treatment of this COVID-19 that we all are facing. And you have shared the importance of this IBM quantum computes. So thank you once again, and it was a really nice thing that we were able to see the relationship that was being shared by this Sultanate of Oman and Indian government as well. So thank you once again to you. Now to move ahead and continue our program with, I would like to invite another eminent personality with us, Professor Krishnenu Vishwas, Professor IIT Kanpur. He'll be talking about the why nanomaterials are very important today. And before that, I would like to share his brief introduction with you. Professor Krishnenu Vishwas is currently working as Ranjit Singh Chair Professor at the Department of Material Science and Engineering of IIT Kanpur, Dr. Vishwas had made significant contribution towards understanding of several important scientific and technological aspects of meteorology and material engineering. His research work mainly focuses on the development of complex, concentrated, high entropy alloys, understanding the solidification behavior of complex, concentrated alloys, novel processing of ceramic composite, understanding the alloy behavior, etc. His recent research activities involves the centering of nanomaterials, graphene, etc. He has published more than 164 papers in international repute journal, and he has completed more than 12 projects, and currently he is working on 4 other projects which has been sponsored by various different institutes or organizations like ISRO, INSA, DST, etc. And he has a collaboration with many other countries like Japan and Germany. He has also received a number of awards, fellowships, and professional recognitions, which includes the INSA Young Scientist Medal, Young Engineer Award, Bicast Fellowship, etc. Now, I'd like to invite Professor Vishwas to deliver his talk on very interesting and informative title, Why Nanomaterials Are Important Today. Professor Vishwas, please. Thank you.
Thank you, Dr. Verma. Can you see my slides?
Yes, sir, we can see your slide.
Just a moment. I'll just change. Can you see change also?
Yes. It's
Okay.
changing.
So at the outset, let me thank Dr. Abnesh Srivastava for inviting me and to deliver a talk to the school children. And so I thank him from my heart. I'll also like to thank CSIR-AMPRI to present some of the things which I'm going to do next 20 minutes or so. So in the dais, we have Professor Dua, who has presented a very nice lecture on uses of computational material science, which is the next generation research area for many of us, or many new kids who are going to take up material science as a career in future. And also we have the director of MNIT and distinguished colleague, and many other eminent scientists, and Dr. Mohammed Akram, who has been following me for the last couple of days. So let me just thank all of them. Well, today I'm going to speak something about why nanomaterials are important. I put nano as a, bold, and also today as a bold. There are reasons for it. Today, I mean today and tomorrow, and or maybe in next 20 to 30 years. And materials are present everywhere, whether you are in the earth, or you are going to moon, or you are going to Mars, you have materials. And we have to survive with the materials. We cannot do anything without material. That is something everybody must understand, that everyday's life, materials are part of parcel of our life. Then why nano and what is nano? That's a very important thing. Nano may be a new word for the young students who are in the school. I'll explain to that. So I'm going to speak something about these aspects, but I may not be able to speak all of them. But mostly I'll speak a lot of applications in today's lecture. So let me start with some examples. So all of you know that if you go on a road and you see these marks, white color marks on the roads, okay, and they're very important. They give directions to take turn, or they sometimes allow you to move on a particular distance. And so how this has to be made very nicely on the road and maintained. And remember, we have millions of kilometers of roads, and if you want to maintain such a kind of structure or such a kind of paint, kind of marker, it's so expensive. And because on the roads, your vehicles are moving, and a lot of polluting gases are coming out from the vehicles, along with dust and many other things actually. And they fall on these white color markers, and then white color markers slowly will be becoming black. So the question is, if I can put a marker which will be everlasting, or I would say which can last as long as possible. So normally if you use tuna, the white line, this will not stay more than a couple of years. And in addition, we have weather changes like high temperature, rain, or cold, or fog. We have everything in India. So how to sustain this kind of marker is a big question. So in this way, an important material which is known as a titanium dioxide. We all know the titanium. And once you add oxygen to it, it becomes titanium dioxide. Why do you call dioxide? Because it has two oxygen atoms. It can also have a single oxygen atom, and that is not a stable compound. So titanium dioxide is not easily available, but can be used. And it has a very interesting property. Remember, all these carbonous materials like carbon monoxide or carbon dioxide or whatever coming out from these fuel burning machines will be falling on these white markers. And anything black, dirty things fall on your dress, white dress in the school when you are going to school, it looks very ugly. So this titanium dioxide immediately oxidizes these kind of dirty materials and make them gas. So in presence of sunlight, in India we have plenty of sunlight. Sunlight is not an issue like in Western countries. So in presence of sunlight, we have UV light mostly, which has a wavelength of less than 400 nanometers. We can excite these electrons from the valence band to the conduction band. Okay, this you may not have heard. Basically, we can excite them to high energy level. That's what you have heard in the school probably. So once these electrons are at a high energy level, they immediately act and oxidizes all kinds of carbonaceous material which is falling on these white kind of things. So they become gas. Once they become gas, they go away. So your white color things went white color. So imagine these things. You can apply these kind of paints on the outside of your house also, so that the walls of the house will remain white and white. That is the advertisement you will see in many of the companies like Berger Paint, Asian Paints, they give the advertisement. So they are using basically titanium dioxide. So this is widely used nanomaterials. Let me tell you, widely used means this is like used in many, many places. Think about food and drugs. Think about cosmetics, which I'm going to discuss with you now, like sunscreen lotions, which you use, or you can use like photovoltaics, photocatalyst, just I have explained you. We can use for drug deliveries, or we can even use for batteries. Think about that. Ink and paints, I have already talked about it. And this is a ceramic, it's oxide. It has to be for ceramic. Ceramic, you understand, ceramic means like a cup and saucer. When you drink coffee or tea, they're made of ceramics. Okay. And so in the kitchen of when you see your mother is boiling some hot coffee or tea, she is going to pour on a cup. That cup is ceramic. So titanium dioxide can be used to make various kinds of ceramic objects. Not obviously this cup and saucer, because that will be very expensive. So how we use sunscreen? You know that sunscreen is widely used by many of us because we have very high temperature, UV radiations. What does sunscreen do? They protect us from UV radiation. All of you are hearing that ozone hole is, you have a layer called ozone in the outer atmosphere, something in like about 80 kilometers above, we have an ozone layer. And that protects us from all kinds of high energy radiations, gamma rays, X-rays, or UV rays, okay? So now some of these ozone layers are getting depleted because of environmental pollutions. And so these areas are subject to high energy radiations from the sun. So, but we have to protect our skin from that. So we use what is known as a sunscreen. In the sunscreen, we use two kinds of nanoparticle, either titanium dioxide or zinc oxide. Zinc you may have heard. Zinc is a very important material against COVID. Okay, all the doctors prescribe zinc tablets. And so zinc oxide is basically oxygen added to zinc. So now these kind of nanoparticle actually, they do not allow the UV radiation to get absorbed on your skin. They will protect your skin from the UV radiations. Okay, that is how they work. So you can see, but the amount of use is very small in the sunscreen lotions, very, very small. It doesn't damage. In the market, you will get two kinds of sunscreen, which will create a white layer once you apply, and the other one which doesn't create a white layer. So the one which creates a white layer, that is what contains titanium dioxide. And that is better actually, in my opinion. So these kind of sunscreens are approved by the FDA, Federal Drug Agency in US. So nanoparticles are, what are these actually? You might be thinking, they are tiny particles of any substance. You can think about it. They are actually having a diameter or distance, thickness or diameter is about less than 100 nanometers. We'll talk about it. So to give you some perspectives, they are what? See, if you take a strand of hair, if we take my hair, okay, it is a little bit thicker than maybe yours. It's about 25 micron. So 1,000 times lower than that distance is actually 1 nanometer. So that means if you reduce the thickness of hair by 1,000 times, okay, 10 times, 100 times, 1000 times, 10 to the power 3 times. Then you get 1 nanometer. And we are talking about 100 nanometers. That means approximately about 100 times larger. That means it's actually how much? Actually, if we reduce here by 10 times, that's what is 100 nanometer is. So you understand the thickness now because everybody can see the hair. So both titanium dioxide and zinc oxide are basically used as an approved material by in India also and the US also, many other places. They give a broad spectrum of UV protection because UV radiation is as a wavelength, like a sunlight, which you see, visible sunlight is a wavelength between 700 and 400. UV also as a wavelength difference. So they protect us from these. So you can see this is how it is used. So we can use in painting, or we can use even in sunscreen lotions. We can use it in many other things. So let me come to another examples. Think about farming, okay? So in farming, we use a lot of pesticides and manure, right? Now, some of you might be helping your father for or your parents for kind of farming. And in farming, we have to inject this thing into the or produce, apply these things to the plants. And the major idea is that we can use something like a porous structure. Something like porous means take suppose some particles which has a lot of open space inside. And when you have open space inside, you can put good material inside the open space. That is called a porous material. And in this porous materials, you can put pesticides, you can put a manure, like manure means what? Something like a nitrogen, phosphorus, or potassium, NPK, or any other manure like urea. You can put it in that, and then you can directly put into the soil, and they will be absorbed by these plants. Okay, because they are nanoparticles, they easily get absorbed, and they can go onto the leaves of the plants very easily. Because leaves are what the factory for the food production in the plants. Well, leaves actually in the presence of sunlight take the carbon dioxide from the air, and you know how carbon dioxide goes. It goes to the stomata, and stomata has a very small hole through which the carbon dioxide molecule goes to the stomata. Okay, and then it reaches in the chlorophyll of the plant, and there you need to put these kind of agents like water or maybe some other things. So that's how we can transport them. So similarly, pesticides also can easily get transported into the plants by using nanoparticles. So you can see that this nanomaterials are pervasive, present in everywhere, whether it's a drug industry or it's agriculture industry or any kind of industry. Nanomaterials are widely used. You cannot avoid them. In fact, they are presently used more, but they were earlier also used about 4,000 years back. We are now understanding it, how it is. So I may not have time to discuss about those aspects, how our forefathers have used this kind of nanomaterials. So now we'll talk about recent example. So, all of you using mobile phones, or you may be watching these things on a mobile phone, or let's say you're watching this thing on a laptop or something. In the laptop or mobile phone, you have a processor, and that processor generates a lot of heat. It's basically doing work. Like when I'm speaking, my processor is my head. So in my head, a lot of heat is generated, right? So body has a mechanism to take care of that heat. But in the processor, there's no mechanism. So that heat has to be taken out. So how do you take out the heat? You can actually generate what is known as a nano heater, or you can use the inverse of nano heater, like a refrigerator actually. In a refrigerator, you cool things down. So refrigerator is the opposite of heater. So you can do the same thing here. You can put these nano heaters, and they can take care of the heat rapidly. They are known as a thermoelectric material actually, and that heat can be then used to generate energy. See, think about a lot of heat generated by the devices like computers, laptops, tops, or phones. You can use this usage to generate electricity. So these kind of things actually uses nanomaterials like this. This is a photograph taken by microscope, which I'll talk a little later. You can see this is basically a device. This is nothing but a nano device, very small dimensions, which will be embedded into your computer to take care of the heat. So you have seen that these four examples, what I told you, they are giving me an idea that we cannot avoid our life without nanomaterials. We have to use such a kind of fine scale material to make our life much faster, much better. And today's world, you will be thinking, talking about maybe after 10 years, wearable nanomaterials. You will wear a dress which will control all your body mechanisms. You must have heard of a watch which people put on the wrist to control heartbeat, to observe heartbeat, blood pressure, many things. So you will have a wearable electronics on your body, and that will provide information to the doctors, and that information then can be monitored to stop somebody's heart failure, somebody's kidney failure. So those kind of things will be futuristic. In the future, you will find this kind of things will happen. So now we give you such example. Now I would like to come to know nano. Nano is a word which is used everywhere. You can have, iPod nano, nano, cafe. You have people has a name like nano. You have a nano car. Okay, Tata has a nano car. You can have a nano mouse. So nano is everything. But then what is nanomaterial? That's very confusing. So I'll come back to it. So nanomaterial is something which is like that. So as I told you, this distance is, you see this a bar here, it's about 100 nanometers. So that means this is actually 1 nanometer, as I told you. If we divide our thickness of the hair by 100,000 times, you get 1 nanometer. And that you need, if you multiply by 100, you get 100 nanometers. This is a linear scale. It is not like any other scale. So these are actually nanoparticles. You see, they are sitting on something like a screen in front of you. And each of these is a dimension less than 100 nanometers. That's why they are called nanometers. So in real world, they have 3 different axes, X, Y, Z. So if any of these dimensions, any of these directions are actually less than 100 nanometer, we call it nanomaterial. It need not be that all the dimensions should be less than 100 nanometer, all the X, Y, Z. If one of them is enough to call it nanometric. Okay, so there are materials in which none of the dimensions are nanometric, but still they are called nanomaterial. But that's a different ballgame to like sandwich structures or polymers. They are there, but forget about those aspects. You should remember only that the 3 dimension in 3D world, X, Y, Z or X, Y, Z, and these out of these 3, if one of the dimension is less than 100 nanometer of any material, we call them as a nanomaterial. Okay, so how do you define it? See it. Okay, we'll see by electron microscope to give you an idea. This is silver. All of you use silver foil on the sweets, and this silver actually can be made nano. Silver is very important. Silver protects us from all kinds of bacteria, viruses. Okay, in fact, God knows silver may be used for coronavirus also. God knows, but this is a conjecture. So this is a gold, you see, and these are all carbon nanotubes. Carbon can come in various forms. Okay, like diamond, all of us like to wear. Or you can have graphite pencils you use, or you can have a nanotubes. Why do you know they're tubes? They're like tubes. See, there's a hole here. Tube is like a cylinder. There's nothing inside it. So they are like nanotubes. And now you have probably heard of this called graphene. Graphene is a wonder material, single layer of graphene. In 2004, Nobel Prize was awarded to the discoverer of graphene. Okay, Mahotsav and there are 2 British scientists who got Nobel Prize for that. So they are actually wonderful materials, but they're all nanomaterials. So that's how things actually happen. And the major use of nanomaterial we know is in catalyst. Okay, like silver and silicon dioxide. You can put silver and silicon dioxide. You can see this is a porous material, all are actually broken. And you can have silver particle inside this. And when the gas, suppose carbon monoxide, is a very dangerous gas from the exhaust of the cars, if you allow them to pass on it, this will transform the carbon monoxide to carbon dioxide, which is less dangerous. But still, carbon dioxide is more dangerous. Okay, but carbon dioxide can be handled because most of the plants actually absorb carbon dioxide, but carbon monoxide cannot be handled by the earth, right? So that's why you have been asked to plant more and more trees. So as an engineer or scientist, we need to convert carbon monoxide or nitrogen dioxide or nitrogen oxide to something else which is more or less actually dangerous, like carbon dioxide or nitrogen. Nitrogen is very not very dangerous because we kind of inhale nitrogen every day from the air. But carbon dioxide is dangerous. Okay, that's why if it increases very large amount, it leads to global warming and all kinds of things. So converting of that to a fuel, like if you convert carbon dioxide to alcohol, that is also possible by catalyst. So all the catalysts in this world are actually nanomaterials. To give an idea of perspectives, this is a length scale. Dust mite, ant actually. Ant is actually about 3 to 4 centimeter long. So, and here is something about 60 to 120 micron. Okay, micron means 1 millimeter. If you divide 1 millimeter by 1,000 times, then one of the division is basically 1 micron. And then you go to red blood cells. All of you have seen the blood. Our blood is red because it has red blood cells. Okay, so these red blood cells actually has a dimension of 60 to 6 to 7 micron. And if you still go down, we have a deoxyribonucleic acid present in every cell of our body, and that's what is the genetic information. And that has a dimension of something like a double helix structure, 2 to 3 nanometers. And then you come to atomic level. That's the silicon. Silicon is widely used in the industry. Silicon Valley, you must have heard in the US. So all the devices is basically made from silicon nowadays. On the silicon has a dimension of less than 1 nanometer, something like 7.8 Armstrong. Okay, so this is how things goes down. You can actually go down the length scale. If you go up the length scale, you can go from the ants to plants to human to even moon to Earth to sun to even galaxy. So you have nice videos present in YouTube. You can see that. So this is the reason I wanted to understand the length scale. That's why I put up this structure. So now, what is the advantage? Scientifically, what is the advantage? Okay, let us do simple maths. Okay, because time is not there, but it's just simple maths. So if I take a cube, think about this cube. Each cube has a length of 1 centimeter. So cube has 6 surfaces. So one surface area is 1 centimeter square. How it is becoming? 1 into 1 is 1 centimeter square. So 6 surfaces, 6 into 1 centimeter square. That's the total surface area, 6 centimeter square. Now I keep this cube same. I divide this cube into many blocks. Each block has a length of 1 millimeter. Okay, 1 millimeter. So if we do that, you will create many things, many cubes, because you are reducing the side of the cube, right? But volume is not changing. My volume is remaining constant. Total mass is constant. I am not changing the mass. All I am changing is the size. So then I can see the surface area is increased to 10 times, 60 centimeter square. So now I want to do another mass. I want you people to do the mass. If I have instead of 1 millimeter as a length of the cube, if I have 1 nanometer, then you can see the increase of area is many times, large, very large. So such a large surface area, what it will do? It will allow more reaction. That's why catalytic reactions are possible. That's why titanium dioxide can convert all the dirty things into gas easily in presence of sunlight. That is the reason. That is why we need more and more nanomaterials in today's world. This is very important for even drug delivery in our body. Okay, think about drugs which are going to different parts of the body. If you can deliver it by these nanomaterials, it is better. And that's why the silicon dioxide comes into a very important material. Remember, silicon dioxide is sand actually. It is present in sand. All the sands you play when you play football or cricket or volleyball, the sand contains silicon dioxide. It's empty, large amount of sands are available in the world. So we have no dearth of silicon dioxide. Only thing is that we should know how to convert silicon dioxide to silicon for our computers and our things. That's a different technology altogether. Okay, now, I'll go back. So, these kind of materials are present in nature. Okay, always. There are many natural sources available. Think of, when there's a splashing of water by a waterfall, you create water droplets, very small. Or think of volcanic eruptions. If you have volcanic eruption, large amount of particles are produced. And this volcanic eruption leads to very small scale particles which are there. Or a sandstorm in Iraq. This is a picture taken in 2005. Or you have a kind of in a natural forest like US in Montana, you have this kind of nice hollow or the twilight structure. Basically, because particles are present in the sky or in the air, they are scattering the light. Okay, that's why you see such a nice, beautiful twilight. You see in India also, those of you who are from villages like me, in the end of the day, when the cows are brought to the home, a lot of dust are produced in the air, and this dust then deflect they scatter the lights, so you can see that. So that's also because of the nanoparticle present. Nano and micro both particles are present there. But most importantly, the natural world is full of use of nanomaterial. Think of gecko. All of you have seen gecko, like they can move on the wall, they can go on the glass floor also. Why they can? How they can go? We cannot go, right? If we want to climb on the wall, we will fall. But they don't, because they have very tiny, kind of hairs on their foot, and these tiny hairs they get deformed when they apply pressure on the wall, and when they get deformed, they get attached, or they take the surface topography of the wall. Okay, so think about that, and that's how they can move. So these tiny hairs are very small, very fine, small. Or think about the color of this nice what is that called? Tiddly. Okay, all of you play with that in your childhood. This is basically because of the different kinds of deflections happening on the surface of these. That's why you see different colors. So many such examples are present. In fact, all the viruses are nano. Okay, think about HIV virus, or think even your coronavirus, they're nanoscale. That's why they can attack you very fast, because they can easily go through our body and go to the lungs easily and attack. So that's why these are natural creations. So nature is full of nanomaterials, and most of the nanomaterials are easily available. We don't have to search, but we have to produce in large quantity for our uses. So how do you do that? Okay, let us go to that. So we can actually produce many ways, actually. Okay, many ways. Hundreds of ways you can produce. So one of the best way to produce is, let me go back to there here. There are two ways we can produce for you. What is that? One is known as a bottom-up approach. Bottom and up. These two words are very confusing for many of you, right? So how can you go? You are at the bottom and you want to go up. So that means you start with a molecule or start with an atom. Let us say you start with a hydrogen. And you then join another hydrogen atom. You create a hydrogen molecule, right? And then you put another hydrogen molecule. You put two hydrogen molecules. And then in this way you can make hundreds of hydrogen molecules. Then you can produce a nanostructure. Okay. Yeah, one hydrogen molecule has a dimensions of something like about 0.5 angstrom. That is 0.05 nanometers. So you need about 100 such hydrogen molecule to make 5 nanometers, right? You do the math very well. So this way you can make many such things. This is basically used by the chemist, mostly used by the chemist to generate. Okay. Or you can do kind of physical way also, like cell assembly. You can use a laser beam to generate such a kind of structures also. Other way is very easy. Break. Take a chalk, keep on breaking it, right? That is called top down. So you have a big thing, you make it become smaller. Do you understand it? Bottom up and top down. These are the two important approaches used to produce all kinds of nanomaterials in this world. Okay, all. There is no other techniques. You can term all the processing routes by this way. So drugs are basically nanomaterials. You don't understand. All the drugs we take, most of them are actually nano. So that's why they get absorbed in the body very easily. So I just go back to now. How do you see that? Okay. How do you see them? We cannot see with naked eyes. So we need some device to see them, right? Without seeing, you cannot believe it. All those pictures I showed you, basically they are there. We can see it. So that's why actually material scientists are expert. Like, you can see our director of AMPRI, Dr. Abnesh Srivastava, he is a very big expert on electron microscopy. So electron microscope gives an idea to see something. So what is a microscope? Microscope is an extension of our eye. Whatever our naked eye cannot see, microscope allows us to see that. You have seen optical microscope in your labs. Okay, that's the simplest one. And it was made by Leeuwenhoek long back in Netherlands, 17th century. Okay. But this electron microscope very recent. They are hardly even, not even 100 years old. So this is scanning electron microscope. So what is done here? Very simple. You have an electron gun, you produce electron beams, and this electron gun is nothing but a tungsten. You have a tungsten, you heat the tungsten up, electron will come out from tungsten. That's what it is. Okay. So these electrons are then focused. Electrons are charged particle, all you know. We can make a magnetic magnet and we can focus them. So that's what is done. You can see these are all focused to this sample. So once the electron falls on a sample at a high energy level, it will do a lot of things. It will knock out electrons, it will go through it, it will produce all kinds of signals like X-rays, it will produce gamma rays, it can produce currents in the things, it can produce other electrons. So these we can then collect. We can collect them using all kinds of detectors. Okay. Basically, basically once you collect them, we can put it on the TV or a computer. Then we can see them. So now question is that how do you see such small thing? Because electron has a very small wavelength. The wavelength of electrons which you're putting is less than sometime a nanometer. So that's why we can see them. Our eyes cannot see. Why? Because our eyes is only using optical lights or whatever is falling on light, then only that's all I can see. And light has a minimum wavelength is 400 nanometers. So you can't see something which is 100 nanometers, right? That's why we need electron microscope. So electrons will allow us to see that. But in scanning electron microscope has a lot of other issues. That's why recently we have established electron microscopes comes into picture. Okay. They are actually fancy tools, very expensive fancy tools. But we're seeing these devices, these machines, they're actually very good machines. So in a transverse electron microscope, you have a very thin sample. Thin sample means its electron will pass through the sample. In this case, electron cannot pass through it. Electron will generate signals. That's how we can use to sample. But here electron has to pass through. That's why it's called transmission. So once it passes through, then you can see atoms. Well, we don't see atoms. We see fields of the atoms. Or we choose the potentials of the atoms. But that's enough. That's enough for us to see atoms. This is actually silicon atoms you see on the screen here. And we can even, determine the distances. Nowadays, they can determine the interaction also. So that's how the science is moving. Okay, science has moved to that level where you can even play with the atoms. So, so you can understand how. But there is another technique called atomic force microscopy, which uses a tip. So what is that? This is basically cantilever. All of you know cantilever. This is a cantilever, right? There's nothing here. There is a hinge here. That's called a cantilever. And at the end of the cantilever, I have a tip. The tip is a very fine tip. It's a dimension of something like about 20 to 50 nanometers. So this tip is then moved on the surface of any surface on the material. Once it's moving on the surface, what happens? It will follow the topography of the surface. Very simple. So once it moves, this is a very fine tip. So atom will interact. Atoms on the sample and the atoms on the tip, they will interact, right? Basically, they will apply force. The atoms in the sample, they may attract it or they may repel it. All of you know that when two atoms come together, they can either attract or they can repel, depending on the distance. Okay, so they will attract or repel. Whatever it is, this will lead to put force on this tip, and this force will then convert into any kind of signal. So then we can plot this force as a function of distance, x, y, z. Okay, and you can see these are all platinum atoms. Okay, PT atoms, very nice dumbbell shape atoms. All of you, your teachers might be saying atoms looks like a dumbbell. Okay, goal dumbbell jaisa likta hai. So this allows us to see even that level. You can imagine this is for this also Nobel Prize was given. For transmission electron microscopy also Nobel Prize was given in 1982, and for this also Nobel Prize was awarded in 1987 or sometime by two scientists in IBM, International Business Machine, which produces computer. Okay, so you can see that without seeing we can't do anything, right? Whatever, whether it's a pesticide, it's a manual, it's a sunscreen lotions, you have to first prove they are nano, then you can add them. So there are three aspects I talked about it in this whole lecture for the benefit of the students mostly. First thing, nano is present everywhere and it will be remaining. You cannot, stop the invasion of nano in our whole world. All the things which you are using today, more and more nanomaterials will come into picture, especially the things which are using as a functional materials. Okay, and secondly, we have to manipulate the nanomaterials if you want to create new things. The way you can manipulate is using this kind of tools actually. So these tools are actually very important. That's why these tools are very expensive. Some of the best possible electron microscope can cost about, say, in India, almost like 50 crores. Very, very expensive. These facilities do exist in India, many places, thanks to government, thanks to the Department of Science and Technology and many other ministries. And this kind of machines are available now. So you can actually take up these kind of research activities and do wonderful things. So if you can help the communities in India, whether it's agriculture, or whether it's a healthcare industry, or whether it's any other industry, that is very, very wonderful things. Okay, so yeah. So as you see, this is a very important plot, which I've taken from this book, nanotechnology towards molecular construction kits, done in Netherlands. And you can see this is how the things are changing. So we are actually in the uprising path of nanotechnology, and this will go on till the probably end of the century. Okay, so if you want to take this path, this is very important. So biotechnology obviously will be also important, but soon biotechnology will saturate. Okay, but nanotechnology saturation will take about 2050 or maybe 2060. So therefore, there's a lot of career in the next. For you people actually, for those who are in the school students. And nanotechnology, many of you probably know that it's sometimes people call it a hype. It's basically like a science fiction. No, there's a real technology now. Even AMPRI, Bhopal, also a lot of polymer research are done there on nanoscale, and many other places actually. So with this, I like to stop here. I hope I have not taken more time. Thank you all for listening to. If you have any questions, queries, we'll be happy to answer. Hello.
Hello.
Yeah, I'm
Yeah,
not.
thank you. Thank you very much, Dr. Vishwas, for such a informative talk that was related to the nanomaterials. You have started sharing your slides with the practical aspect for the utilization of nanomaterials with all of us. You have shared few of the examples of titanium dioxide, zinc oxide, how they can be used for sunscreen lotion and other things. Along with that, you have talked about the importance of nano devices in electronic as a component, and you have also shared that how these nanomaterials can be produced by two approaches, bottom up and top down approaches, and then how beautifully you have correlated the talk that we all are suffering from this COVID-19 coronavirus, that it is also a nano virus and how it is entering, why it is entering. You have touched this aspect also. And at last, you have shared that when we are talking about the nanomaterials, how we are going to see this nanomaterial by using this electron microscopy and AFM. Thank you so much. It was really a very, very wonderful and knowledgeable talk, Dr. Vishwas. Thank you. So, ladies and gentlemen, now to move ahead with our celebration, now we have with us a very, very young and dynamic guest, Dr. Rajni Verma. I am glad to share with you that she has joined with us long way from Australia. She is there and she has accepted our invitation to celebrate this Azadi Ka Amrit Mahotsav with all of us. I welcome you and thank you again, Dr. Verma. She'll be talking about the nanomaterials, the futuristic approach. To call her before that, I'll introduce you with her. Dr. Rajni Verma is currently, she is working as Mackenzie Postdoc Fellow, which is a highly competitive and prestigious fellowship in the School of Physics, University of Melbourne, Australia. She is awarded PhD from CSIR National Physics Laboratory. Her PhD topic was Oxide Nanomaterials, Synthesis, Characterization, Optic and Biological Responses. She has published around more than 18 articles in high quality journals with one book chapter, and many other papers are under review and in the process of publication. Till now, she has more than 260 citations and 10H index. And now I'll call her to talk about the nanomaterials, the futuristic approach. Dr. Verma, please.
See my slides?
Yeah, please.
Thank you for the nice introduction. Firstly, I would like to thank everyone, the organizers and also the director of CSIR-AMPRI to provide me this fantastic opportunity to interact with students, teachers, scholars and scientists at the same platform. So I'm so thankful to you, and I welcome you all to my talk, which is about nanomaterials futuristic approach. So in my talk, I will be discussing about their basically nanomaterials, their definition, their how like what are the types of nanomaterials and how these nanomaterials can be synthesized, can be processed with the different chemical and green synthesis routes, and then how can these nanomaterials can be used in various science and technology related applications. So
Excuse me, Dr. Burma, your voice is very low.
oh, okay.
You are not able to hear properly.
Is that okay now?
No, not yet.
Not yet? Okay, just a minute. I hope.
Yeah, now it's okay.
Okay. Thank you so much. So thank you so much, Dr. Sarika ma'am, to introduce me. So myself, Rajni Verma from University of Melbourne. So just a brief introduction that I joined University of Melbourne in 2019, and my project is basically on nanomaterials to utilize these nanomaterials for biological applications. And I completed my PhD from CSIR National Physical Laboratory, Delhi, under the supervision of Dr. Avnesh Kumar Srivastava, who is currently the director of CSIR-AMPRI. And my thesis title is Oxide Nanomaterial Synthesis, Characterization, Optical and Biological Responses. So basically, the outline of my talk includes nanomaterials, some natural nanomaterials, types of nanomaterials, their various synthesis processes, chemical methods, and what techniques I have used during my doctoral and current studies, and also their applications, mainly their biological and environmental applications. So, as Professor Bishwas has already elaborated you about the nanomaterials. So yeah, so what are nanomaterials? Mainly, nano is a Greek word and it means dwarf. So nanomaterials are very small material, and the material having at least one dimension in the range of 1 to 100 nanometers. You can even think that even the single hair of a human is 1 lakh nanometers. So you can think that nanometers are very small in the range of 1 to 100 nanometers. So these nanometers can be of different morphologies. They can be spherical, they can be elongated, they can be planar. And also there are various natural nanomaterials. So nature is the best example of nanotechnology. So such as butterfly wings. If we talk about butterfly wings, so butterfly wings, they have got nanostructured materials. And those materials, when they interact with light, so they constructively reflect the light, and that produces very intense color. And thus the butterfly looks so beautiful, so pretty. And similarly, the beetles and spider, and in case of gecko, lizard, what happens there in their feet, we have nanofibril structures. So that nanofibril structure help to firmly attach it with the surface. So nature is the best example of nanomaterials. So there are different types of nanomaterials. Like there are metal nanoparticles such as gold nanoparticles, silver nanoparticles. Silver nanoparticles are best for antibacterial applications. Also, there are carbon nanoparticles like carbon nanotubes, like graphene. There are magnetic nanoparticles, so the nanoparticles which can be manipulated in the presence of magnetic field. I will show a very interesting video over it. And there are dendrimers. There are biodegradable and biocompatible nanomaterials like zinc oxide, titanium dioxide. So in this way, there are different types of nanomaterials for different applications. So yeah, so what are the properties of nanomaterials, and how the properties of nanomaterials are different from the bulk material? So such that we can take this example, such like we have a bulk material, and when we are slicing it up to the nano regions, then what is happening, this mass of bulk is remaining same, but their surface area is increasing. So the available sites to interact with the environment are increasing. So more interactions possible, and thus it leads to the difference in their properties, like optical properties, melting point, electrical conductivity, chemical reactivity, chemical reactions. So what is happening, if you have the different particles of a different size of particles, such as this gold nanoparticle of different size, the change of these nanoparticles solution occurs from red to purple. So different size of particles, different interactions with light, and they show different colors and different properties. And they can be used for the different applications. So there are nanomaterials are involved in lots of applications. They are like omnipresent. They are in biomedical applications. They have different industrial applications, environment applications, agriculture applications. So they are used in food as well. So in food, they are helping to absorb the nutrients, more absorption of nutrients, and not only in the food, but they are also used for food packaging, because they help to inhibit bacteria. So in this way, prevent the food from spoilage. So they act as they are present in food, they act to inhibit bacteria, they act to inhibit cancer cells, even they are helpful in water purification, they are even used in bioimaging, they are even used in sunscreens. So why sunscreens? Because they are good UV absorption. Good UV absorption phenomena, like TiO2 and zinc oxide are mainly used in sunscreens. Yeah, so these applications I will elaborate you further. So yeah, so if you have a desired application, so how you are going to like, there are different stages. You should know what are the types, what should be the type of nanomaterial that fit for that application, then how you are going to process it, then how you will characterize it to make sure that, yeah, that nanoparticles have been formed of that desired properties, and then you will use it for that application. So there are different ways to process these nanomaterials. Like you can, like as we do in our labs, like chemical reactions can be used using photosynthesize these nanoparticles. There are physical methods, there are biological methods, green methods. So what we really do in the chemical synthesis of nanoparticles, we take precursor. Suppose if we are using like gold nanoparticles, so we should have a gold precursor, say chloroauric acid, and then we will use sodium citrate as a reducing agent, and then we will stir it at some specific temperature with some specific experimental conditions to get the gold nanoparticles. Similarly with zinc, if you want to synthesize zinc oxide nanoparticles, you should have some zinc precursor, you should have some reducing agent, and but the thing is, the advantage of this method is that you can control the reaction conditions to get different morphologies or different types of nanoparticles for different applications. So this method is very simple, and it helps for the high production of nanoparticles. Yeah, so I have synthesized zinc oxide nanoparticles at CSIR National Physical Laboratory. So these particles, yeah, which are synthesized from chemical methods, and I used polymer to stabilize those nanoparticles. These nanoparticles look very uniform, like their size and shapes look very same. Similarly, not only nanoparticles, I have also synthesized zinc oxide nano rods, nano fibers. So I just changed the chemical methods, some conditions like the change in precursor concentration, change in solvent composition, that led me like these kinds of morphologies. So I use them for the different applications. So these are the SEM and TM images. SEM and TM are used to determine the shape, size, the morphology of nanomaterials. Similarly, for green synthesis of nanoparticles, if you want to synthesize nanoparticles which are more biocompatible, which if you want to use some nanoparticles for biological applications, then green synthesis is the best method. And so this is the very clean, very eco-friendly method. So what we use in green synthesis, we just use the plant extract or microbes or even proteins to synthesize those nanoparticles, such as if you want to synthesize ZNO nanoparticles, then these can be synthesized even from the orange peel. You have to just take the orange peel, you need to ground and dry them. Then the obtained powder can be like make it a solution, then add it with the zinc precursor, and then you will get, add some specific experimental conditions, you will get zinc oxide nanoparticles. So similarly, along with zinc oxide nanoparticles and nanorods, I have also worked on TiO2 nanoparticles. And to make it more biocompatible, I mainly coated these nanoparticles with green tea. So green tea, it is mainly having polyphenolic moieties. They are having apigallocatechin gallate, which is the polyphenol. And so we have seen a mechanism that the polyphenolic moiety present in the green tea, it interacts with the TiO2 surface. And we also have seen that the morphology were found to be changed, as these were found to be more uniform after using green tea. So yeah, I used these nanoparticles for degradation of dyes. Yeah, this is a very interesting video on magnetic nanoparticles. So what happens when, as I already told you, that magnetic nanoparticles, when they come under the influence of magnet, they show some spike-like pattern. So yeah, so this is the magnetic fluid, which is composed of magnetic nanoparticles with some carrier fluid. And when when it is coming close to this permanent magnet, it is showing some spike patterns. Yeah. So after synthesis, we should like nanoparticles are very small. They are not easy to be seen directly. So we need specialized powerful microscopes to see them. Like, so if you want to check whether the nanoparticles have been formed or not, or which nanoparticle is there, is it ZNO or ZNO2 or TiO2 or like that. So you should go for XRD, FTIR, EDAX. And then if you want to check whether the nanoparticles, like what size of nanoparticles have been formed, is it rod shaped, is it particle shaped? So you should go for SEM, TEM. Then for optical characteristics, UV and PL, and then for biological studies to just check whether they are biocompatible or not. So we should use these like MTTSA. So yeah, so nanomaterials, they have various applications. So one of the main application is air and water purifications. So what happens when these nanoparticles, when they interact with the light, like UV light, then they produce reactive oxygen species. So what these reactive oxygen species do, they help to eliminate these VOCs, volatile organic compounds, and NOxes from the air, and thus they help to clean the air. Similarly, they also help to eliminate bacteria, germs, fungi from the air and water, and thus they are helping to clean the environment. So like ZNO and TiO2 are well known for the photocatalytic applications. Then they also have one more application, that photo degradation of microplastic, which is also very useful. So as we know that plastics are important, but they are also causing hazard to the environment. So burning of plastic is not a way out, because that might emit some very toxic gases. So here comes nanotechnology. So using TiO2 nanoparticles, you can even degrade those microplastics such as polystyrene or polyethylene into the small molecules such as CO2, which further can be reduced into useful chemical solvents. So this is the green and sustainable method for microplastic degradation from the environment using TiO2 nanoparticles. Nanoparticles, they also show inhibitory process against microbes. So when nanoparticles, when they interact with bacteria, so they inhibit their cell wall formation. So they try to attack different parts of bacteria. They will either inhibit cell wall formation, or they will try to attach to the surface of cell membrane. They will also undergo photocatalysis phenomena and produce reactive oxygen species, which again help to eliminate those bacteria. So they are also helping to eliminate bacteria. They are acting as antibacterial agents as well. Similarly, they are used for bioimaging. Like MgO nanoparticles, I have used for bioimaging applications. So what I did, I firstly synthesized MgO nanoparticles, and then yeah, this is the SEM image of which shows that the nanoparticles are like fibers in the fiber form. And then these nanoparticles were dispersed in the solution and broadcasted on the glass slide, and then they were checked, like their fluorescence was checked using under confocal microscope. So our idea was we don't want to use any dyes, because that might change the dynamics of the process. So we are just using MgO nanoparticles as it is, and we are using its autofluorescent properties to bioimage the like for bioimaging. So for that we use human skin cells and human brain cancer cells as well. So this is the example for human skin cells. These are the skin cells under 390 nanometer excitation. But yeah, these were tagged with dyes, the DAPI dye, which excites at 390 nanometer, and these are the human skin cells with MgO nanoparticles. So when these were excited at 590 nanometer, we could see these nanoparticles somewhere at the cell membrane. So we checked the potential of these nanomaterials for bioimaging applications. Similarly, we coat these nanomaterials with the silk as well to enhance its fluorescence. Yeah, so as you know that COVID is affecting our lives, like COVID is highly contagious, and it is highly deadly virus. So to combat the infections caused by the COVID-19, nanotechnology enables nano PPE. So like face mask, we have hand sanitizers, we have medical aprons. So these nanoparticles are hydrophobic, they are water repellent, they also help in as you have seen that they also show antimicrobial properties, not against bacteria, but they also inhibit multi-drug resistant bacteria, biofilms, and also viruses. So these nanoparticles, they are playing very important role to combat these infections. So the thing is that the nanomaterials are omnipresent. We are just surrounded with nanomaterials. Nanomaterials are like we are using them in our everyday life. So, but still there are some challenges. So what are challenges? That are these nanoparticles really safe to use in for humans, for aquatic species, or for environment? Or are these nanoparticles photostable? Because if we are using them in bioimaging applications, so they need to be stable. Also, are these nanoparticles show stability in aqueous solutions? Are they stable enough to be, because as we know that our body is mainly made up of aqueous solution. So if we want to use these nanoparticles in biological applications, so these nanoparticles should be stable enough. So, and also visible light catalyzed reaction. So we have seen the TiO2 and ZNO, they absorb UV light. So can we modify these nanomaterials such that they can be used for visible light catalyzed reactions? So still the researchers are working, and we are still finding the solution of these challenges. Yeah, so this is just a general data over international students. Like Australia is a very hot destination for international students. So like you can see, even in this COVID scenario, around 5 like international students came in June 2021. And there are top 5 countries, and among those top 5 countries, India is one of them, from where the students are coming here. And yeah, so it's just a very nice environment, very good living conditions. So yeah, this is these are some pictures I wanted to share with you. This was during the Boxing Day match, like in Melbourne cricket ground. I with my husband, we went to Melbourne cricket ground, and yeah, we were fortunate enough. Yeah, so, and India also won at that time. Thank you so much. If you have any questions, please feel free to ask. Thank you.
Thank you. Thank you, Dr. Rajni, for a nice presentation. It's really an interesting way, the way you have presented the importance of nanomaterials, starting from its types, and then you have specifically talked about those nanoparticles like titanium dioxide, zinc oxide, and their structures, how they are different, like spherical photographs you have shown. You have shown the nanorods as well. Then you have shown a beautiful, very interesting, excited video as well to show the difference of these magnetic nanoparticles, how they are reacting. And then you have correlated the importance of these nanoparticles in the application form, that how we can use this for the microplastic degradation as well as an antibacterial agent. And then it was actually a good start from the end. It was a very interesting talk. I'm sure our audience, our students have got a very good practical knowledge about these nanoparticles. And yes, the futuristic approach that you have touched is really very means thoughtful, that how we have to go in the near future along with these nanoparticles, so that we can have a minimum of the side effect of these nanoparticles. And wonderful picks, of course. Thank you once again, Dr. Rajni, for this nice talk. Thank you. So now, ladies and gentlemen, to move ahead, we are in between of the program, and all of us worldwidely, globally, for last more than 1.5 years, been suffering from COVID-19 pandemic. And several efforts all over the world at our own level we have been making for its mitigation, for how to control this, and for spreading the knowledge and about this COVID-19 pandemic. With respect to this, CSIR-AMPRI Bhopal has immensely contributed towards this particular COVID-19 problem. And for related to that, we want to share a short documentary movie on AMPRI's R&D work that has been related to this. And for that, I would again request my colleague scientists from ID department, Shri R.S. Ahirwaji and Shri Naren, to kindly screen this movie. Thank you.
CSIR Advanced Materials and Process Research Institute, in short we call it CSIR-AMPRI at Bhopal, is one of the constituent labs of CSIR, that is Council of Scientific and Industrial Research. Under this lab of CSIR, that is at AMPRI Bhopal, we work on lightweight materials, smart and functional materials, nanostructured materials, waste to value-added materials. And these materials, in turn, they get converted into different outputs like publications, patents, and products, that is technology know-how transfers. It's a national lab of international repute. As far as COVID-19, this pandemic of coronavirus is concerned, we worked on different directions. Being an engineering lab, we try to do our best using our capacity, efficiency, and the expertise of our scientific, technical, and non-technical manpower. We worked on knowledge generation, knowledge dissemination, industry interface, societal interaction, and innovative products. In terms of knowledge generation, we published some very important papers in international journals, including even considering the nanomaterials of graphene, and we are probably the first in the world to publish in Science Reporter saying that graphene can work as a protection material against coronavirus. Other publications like on antimicrobial coating, biosensors, medicinal plants, and so on. Then we did knowledge dissemination, like organizing conferences, workshops, training the people, and also making aware how to protect yourself, how to prevent yourself from the COVID-19. We had these programs under Jigyasa, teaching the school students, their parents, their teachers, their deputy commissioners, principals, and under skill development program, certain programs we have run. Then we interacted with society in terms of teaching them or making aware how to protect themselves from coronavirus. In this case, we reached to more than 50 villages of Madhya Pradesh and Chhattisgarh. We distributed our masks, sanitizer, soap, and posters, making them aware about the coronavirus, COVID-19. We also distributed our soaps, masks, then sanitizer, and posters to government officials like police personnels, bank officials, and common man. Then further we worked on different products, technologies we are trying to develop, and we started with face mask and sanitizer with extra skin care. And this technology we transferred to a startup company in Indore, and I'm happy to tell you that face mask is already in the market. It's commercialized after lab testing, and sanitizer work is going on. In addition, we are working on to develop different sanitizer boxes with UV and nanomaterials, hybrid boxes, without UV with nanomaterials, hybrid boxes. We are developing some other products like some biosensors and so on. Then we are working on different other products like different high quality masks like e-mask, tribological mask, herbal mask, graphene layer incorporated mask for different sectors of the people, not only to common man but even for doctors and other healthcare people. So in total on different fields we are working. We are developing into antimicrobial coating to protect ourselves from this COVID-19 coronavirus, and this coating can be used for different metallic surfaces, and therefore one can protect ourselves. So in total in 5 directions of knowledge generation, as I said, knowledge dissemination, societal interaction, industry interface, and innovative projects. In all these directions, our scientists, technical staff, non-technical staff, students, project fellows, we are working in one team, and we are also getting associated with CSIR as a whole. CSIR as a whole also has 5 pillars where different directions they are working, and we are associated with hospital assistive devices among 5 pillars of CSIR. With this, thank you very much. Jai Hind. Dhanyavad.
Thank you. Now, to continue the program with, I would like to invite my colleague scientist, Dr. Sultanate Mishra, senior scientist, to share the insight about the Jigyasa program and the AMPRI's work and the contribution towards it, and also to further continue the program. So thank you from my side, ladies and gentlemen. It was really a very, very nice and delighted experience with you all for me to celebrate, to have this unique celebration of 75th year of independence as Azadi Ka Amrit Mahotsav and 80th year of CSIR, that celebration that we are doing. Thank you so much to all of you from my side. Sadan Mishra ji, please continue.
Thank you, madam. A very warm good afternoon to one and all present here. Chief guest of today's program, Professor N.S. Raghuvanshi sir, Director, Maulana Azad National Institute of Technology, Bhopal. Our Director sir, Professor Abnesh Kumar Srivastava. Guest of honor, Dr. Krishnau Biswas, Professor, Department of Material Science and Engineering, Indian Institute of Technology, Kanpur, and Dr. Piyush Dua, University of Technology and Applied Science, Sohar, Oman. Dr. Rajni Verma, McNeil Postdoctoral Fellow, School of Physics, University of Melbourne, Australia. Mr. P.S. Sardar, Deputy Commissioner, Navodaya Vidyalaya Samiti, Bhopal region. Mr. Somi Srivastava, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Bhopal region. Mr. Vinod Kumar, Deputy Commissioner, Kendriya Vidyalaya Sangathan, and Mr. Tajuddin Sheikh, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Jabalpur Region, Assistant Commissioner, Principals, teachers, students, our own institute, scientists, officers, official and research scholar, a very good afternoon and welcome here again. As you know that we are virtually connected here for celebration of Azadi ka Amrit Mahotsav and 80 years of CSIR at CSIR-AMPRI Bhopal, along with journey of CSIR Jigyasa program. I am highlighting here some glimpse of CSIR Jigyasa program. The Jigyasa aims to inculcate the culture of inquisitiveness on one hand and scientific temper on the other among the school students and their teachers. CSIR Jigyasa program is a significant milestone event. CSIR has signed the Memorandum of Understanding with Kendriya Vidyalaya Sangathan on July 6, 2017 to launch Jigyasa program in the gracious presence of Honorable Minister of HRD and Minister of Science and Technology and Earth Sciences and Environment, Forest and Climate Change. On March 13, 2020, an MOU was again signed between the Council of Scientific and Industrial Research CSIR and Navodaya Vidyalaya Sangathan to implement Jigyasa. The program is accepted to connect 1,151 Kendriya Vidyalaya and 6,061 Navodaya Vidyalaya with 38 national laboratories of CSIR, targeting 1 lakh students and nearly 1,000 teachers annually. The aim of MOU is to connect CSIR institutes with school students and teachers to develop scientific temper in the young minds. Around 20 models of the engagement has been proposed, which we have been implementing in school students for the creation of scientific temperament and preparing future scientists of the nation as well as world. On the grand success of CSIR Jigyasa program, CSIR has launched the CSIR Virtual Lab program on pilot mode in the session 2020-21. In the program, we prepare scientific videos, quiz and competitions, comics, simulations, animations, games, models, and exhibits, students, innovations, etc., and made it very effective and attractive learning process. On the grand success of pilot program, CSIR again launched CSIR Virtual Lab 2.0 program for the 5 years from 2021 to 2026. CSIR signed an MOU with IIT Bombay for successful running CSIR Virtual Lab 2.0 program, and we are uploading the content on IIT Bombay server on GitLab platform. CSIR also started the journey of mentoring Atal Tinkering Lab with Association of Niti Aayog. Under CSIR-AMPRI, 15 schools are assigned for mentorship of Atal Tinkering Lab. We feel proud to share with you CSIR-AMPRI is benefited more than 85,000 students and teachers under CSIR Jigyasa program till date. We are delighted to have with us Mr. P.S. Sardar, Deputy Commissioner, Navodaya Vidyalaya Samiti, NVS Bhopal region. Mr. P.S. Sardar currently working as Deputy Commissioner at Navodaya Vidyalaya Samiti, RO Bhopal, covering 3 states as Madhya Pradesh, Chhattisgarh and Odisha state. He has nearly 34 years of experience in the education department. Now I request to Mr. P.S. Sardar sir to address the session. Mr. P.S. Sardar sir.
Thank you, sir. Thank you very much. Am I audible, sir?
Yes, sir. Yes, sir. You are audible.
Thank you. First of all, I would like to thanks to Director CSIR, Srivastava sir, and Misra sir for giving me this opportunity to talk on the topic of development of education in India after independence. All of us know that before independence, there were very few schools in our country, and literacy rate was also very slow. Very slow. That was 19.3, and now it goes more than 74%. After the implementation of 5-year plans, efforts were made to spread education. Government decided to provide free and compulsory education to all children up to the age of 14. But this aim could not be achieved yet. Still, there are some students. In second and third plan, the allocation were 5.8% and 6.9% of the total plan outlay. And in ninth plan, only 3.5% of the total outlay was allocated for education. But still, there are more than 20 lakh schools in our country, and 37.4 million students are studying in the schools. To streamline the education, the government implemented the recommendations of the Kothari Commission under National Policy on Education in 1968. The main recommendations were universal primary education, introduction of new pattern of education, three-language formula, introduction of regional language in higher education, development of agricultural and industrial education, and adult education. To combat the changing socio-economic needs of country, Government of India announced a new national policy on education 1986. Universalization of primary education, vocationalization of secondary education, and specialization of higher education were the main features of this policy. NCRT at national level and SCRT at state level were established to maintain the standard of education. UGC was also instituted to determine the standard of higher education. During the period of planning, there has been expansion of general education. All of us know. In 1951, the percentage of literacy was 19.3, whereas in 2001, literacy percentage increased to 65.4%, and now more than 74%. The enrollment ratio of children in the age group of 6 to 11 was 43% in 1951, and whereas now it becomes 100%. Primary education been free compulsory. Midday meal has been started in school since 1995 to check dropout rate, and the number of primary schools has risen by 3 times from 2.10 lakh, which was in 1950-51, to 6.40 lakhs in 2001 and 2. Now it goes to 20 lakhs. There were only 27 universities in 1950-51, which increased to 254 in 2000-2001, and now it goes more than 1,000 universities in different areas. Besides general education, technical education plays important role in human capital information. The government has established several industrial training institutes, polytechnics, engineering colleges, medical and dental colleges, IITs, NITs, IIM, medical colleges, agriculture colleges, and we see the growth in the field. In India, literacy among women was quite low. It was 52% according to 2001 census, and while literacy among men was 75.8%. But now it goes beyond 74%. Women education was given top priority in national policy on education. Many state governments have exempted the tuition fee of girls up to university level. Separate schools and colleges have been established to raise level of literacy among women. And at the same time, National Policy of Education 1986 aims at vocationalization of secondary education. Central government has been giving grants to state governments to implement the program since 1988. Agriculture, tissue culture, dairy, poultry, typing, electronics, mechanicals, and carpentry etc. had been included in higher secondary curriculum. In 1951, there were 27 universities, as you know, and in Odisha state itself, there are now more than 27 universities. At the same time, the government of India focused on non-formal education also. This scheme was launched on the experimental basis from 6th plan and on regular basis from 7th plan. The aim was to achieve universal elementary education to all children in the age group of 6 to 14 years. The scheme was meant for those children who cannot attend school regularly and for full time due to proper preoccupation with other work. The central government is providing assistance to state government and voluntary organization to implement the schemes. Non-formal education centers have been also set up in remote rural areas, hilly area, tribal areas, and in slums. These impart education to children of 6 to 14 age group. Now, after adoption of national policy of education, regional languages became the medium of instruction in higher education also. Syllabus on science and technology, dictionaries, books, and question papers are translated into regional languages. Indian history and culture have been included in school and college curriculum after independence. Adult education also proposed. Simply speaking, adult education refers to the education for the illiterate people belonging to the age group of 15 to 35 years. The National Board of Adult Education was established in the first 5-year plan. The village level workers were assigned the job of providing adult education. The progress remained not too good, as we know. The National Adult Education Program was started in 1978. The program is considered as a part of primary education, and next to that, National Literacy Mission was also started in 1988 to eradicate adult illiteracy, particularly from rural areas. The centers gives assistance to the state voluntary organization and some selected universities to implement this program. There were 2.7 lakh adult education centers, 2.7 lakh adult education centers working in the country in 1990-91. And this program helped to raise the literacy rate to 65.38 now, and now it goes 74.37. And improvement of science education also have been taken place. Central government started a scheme for the improvement of science education in school in 1988. Financial assistance is given to provide science kits, upgradation of science laboratories, development of teaching material, training of science and mathematics teachers. A Central Institute of Educational Technology, CIET, was set up in NCRT to purchase equipment for State Institute of Education Technology. As all of us know, that the government has taken a lot of steps to improve the education. And now, if we talk about this National Education Policy 2020, that too also there is a lot of changes. All of us know. I will not go in detail. According to 93rd Amendment, education for all has been made compulsory. The elementary education is a fundamental right of all children in the age group of 6 to 14 years, and it is also free. To fulfill this obligation, Sarva Shiksha Abhiyan has been launched. Now it is clear that a lot of development in education has been made in India after independence. There is wide growth in general education and higher education also. Efforts have been made to spread education among all sections and all regions of the country. But still, there is a scope to work hard on it, and education system is ridden with problems that we have to solve it. And in the field of education, all of us know that there are scientists, those who are working on it, and we are going to implement the National Education Policy 2020, in which the focus on the skill-based education and language mother tongue is given. With this, finally, I would conclude that during this period from independence to today, there is a lot of improvement and changes in the field of education. Dear sir, you have given me this opportunity to put forth before all of the scientists and educationists the development of education in India after independence. Thank you. Thank you very much.
Thank you, sir, for your wonderful start. We are pleased to have with us Mr. Srivastava, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Bhopal region. Mr. Srivastava is currently working as a Deputy Commissioner, Kendriya Vidyalaya Sangathan, Bhopal region. He has started his journey in 1993 in Kendriya Vidyalaya Sangathan, and he also joined as an education officer in 2004. Now I would like to invite an eminent personality, Mr. Srivastava, to share his words on this auspicious occasion. Mr. Srivastava, sir.
Thank you, Ms. G. Director CSIR-AMPRI, Srivastava, other and my dear teachers and students. First of all, a very warm good evening to all of you. We are meeting Jigyasa. All know Jigyasa is a unique initiative of the government of India, and through this initiative, the student community is being approached by the scientist community, and to motivate student community to take up career in research and development. Under this Jigyasa initiative, many programs have already been extended to students and also teachers. Teachers also have been greatly benefited. So on behalf of Kendriya Vidyalaya Sangathan, I thank CSIR-AMPRI and CSIR in general for their contribution, for all the knowledge that they have disseminated to student community and teachers community. As you all know, dear friends, that this year the government of India has decided to celebrate 75th Independence Year in year of independence as Mahotsav. This is celebrated with a great enthusiasm across the country. All organizations, particularly school organizations, they are holding various programs and are in fact are meeting students with great freedom fighters and their unique contributions. In particular, we've been asked to in turn ask the student to find out the details of such unsung heroes and heroines who also contributed in the freedom struggle, but somehow their names could not be written in the popular literature of freedom struggle. And we are on that work, and I hope that more unsung heroes, their names will emerge as a part of it. Now, my colleague from NVS has actually brought out the various strides that the government of India has taken to bolster the education infrastructure of this country in the last 75 years. As you all know, that in 200 years that Britishers ruled India, their objective was one-pointed. They were here for exploitation. They exploited us. They exploited our resources, and they exploited the mutual bickerings of local kings to their advantage. And they also set up an education system which actually suited their advantage. So such was the condition of education and India during the 200 years of colonization. 1947, 15th of August, we became independent. And at that time, the status of education was not great. The literacy rate was low. The condition of women's education was falling. The schools were without proper infrastructure, and the dropout ratio was enormous. And such fierce conditions the country faced at the time of independence. But soon after independence, the government of India, with the help of all those who could contribute, we started making rapid strides to improve the education infrastructure. All those steps have started bearing fruits. The literacy rate has improved, the education infrastructure has improved, the quality of education also has improved, and the launch of National Education Policy, NEP 2020, more such reforms will be launched. Many have already been launched, many are in the offing, and more improvements you all will witness in the years to come. Now, one particular thing that I have noticed in NEP is that it lays a lot of emphasis in popularizing the traditional knowledge system. You all know during the 200 years of colonization, the traditional knowledge system systematically destroyed because Britishers were not interested. They never wanted Indians to feel proud of being Indians. So that is why their whole purpose, their one-pointed agenda was to somehow augment the Western values, the Western knowledge system, and systematically destroy the traditional knowledge system of India. Now, through NEP, the government of India has made its intention very clear that we bolster the traditional knowledge system. You all know, if you read the ancient history of India, my dear student, you will find that traditional knowledge system in India was very robust. And we need to connect our students to this vast repository of knowledge which existed in India, and our present day students are largely cut off from that huge reservoir of knowledge. The knowledge that is enshrined in Upanishads, in Vedas, in scriptures like Bhagavad Gita, this knowledge, this huge reservoir of knowledge, unfortunately, our students are so that vast reservoir of knowledge that existed once very proudly in India. So I'm quite happy and very delighted that NEP squarely addresses this concern, and it makes us, in fact, alive to this that they use traditional knowledge. And I hope that the students will find ways and means. The students will be encouraged to explore various ways and means to connect themselves directly to this huge, vast reservoir of knowledge. Unfortunately, today's youth still believe that the traditional system somehow linked only with these, only with religion, so to say. But that is not the case. If you read the ancient literature of India, it is full of mathematics. It is a lot of science in that. Astrology, astronomy, all dimensions of science, you will find they are the Indian knowledge system is entrenched in all these directions. Astronomy in particular, medicine is also a case in point. Metallurgy is a case in point. So in all these areas, during the 100 years of colonization, we had forgot the European education system and the youth of India, in fact, he became oblivious of his own wealth, of country's own wealth. But NEP is spiral against this need. It in fact makes all those people who are connected with the education system, makes them responsible to reestablish this lost connection. I hope that during this Amrit Mahotsav, the teachers as well as and all those who are connected with the education system, they will also discover ways and means to reconnect our student community with this lost resource. And I hope that students and teachers, they will explore every opportunity that comes their way to reestablish this connection. I'm thankful to Director AMPRI for giving us a series of such opportunities whereby the students get exposed to the frontier researches in material science. And in fact, today's 3 lectures that we heard, that we in fact watched, were very were full of knowledge. And in fact, I have been greatly, in fact, I watched all the presentations very keenly, and the presentations on nanomaterials and nanotechnology and all the substances, materials that are being developed by AMPRI and
Thank you, sir, for your kind words. And we are happy to have with us Mr. Vinod Kumar, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Raipur region. Mr. Vinod Kumar is currently working as a Deputy Commissioner, Kendriya Vidyalaya Sangathan, Raipur region. He has joined Kendriya Vidyalaya Sangathan in August 1995, worked in almost 5 states of India during last 24 years of career in Cape Beach. Now I request sir to address the session. Vinod Kumar sir, please.
Thank you, Dr. Mishra. First of all, good evening to all August members in this webinar. The chief guest of this webinar, Dr. N.S. Raghuvanshi, Director, Manit Bhopal. The speakers, Professor Krishanu Vishwasji, Professor Piyush Duaji, and Dr. Rajni Verma ji. Especially the Director, Abnesh Kumar Srivastava, Director CSIR-AMPRI, who is giving a lot of exposure to our children of 3 states, like 3 regions, Jabalpur, Raipur, and Bhopal. We are thankful for the CSR with the collaboration with Kendriya Vidyalaya Sangathan, so that our children are getting exposed to the new innovations which are happening in the field of science. So far as Kendriya Vidyalaya is concerned, we know that we are imparting quality education to the children. But when the children are exposed after class 12 to the real world, they interact with the senior scientist through their graduation course, post-graduation course, and then doctorate degree. So this effort of signing MOU between CSR and KVS is putting an environment which is much needed in the present scenario, that how to collaborate industries, the inventions which are happening in the field of science with the small children of the schools. This present year started from the March itself, the 75th year of independence, and which is rightly named by our Honorable Prime Minister, Azadi Ka Amrit Mahotsav. And I'm happy that CSR is also commemorating its 80 years of foundation in the India from 1942. when Mr. Mishra contacted me three, four days back, I was just thinking how to relate these two words, Azadi ka Mahotsav and the CSR itself. I was just Googling, just went to the Google, and I saw that what was the role of scientists during freedom struggle. Is there any relation that our freedom fighters are motivated due to some scientists? I found few names which those who are working as scientists or who have done doctoral degrees or postdoctoral degrees at the time. I'll name few of them, that J.C. Bose, P.C. Roy, and P.C. Ved, Homi Bhabaji. I was just going through what their work and their motivation at the time. I found though they are not directly related with the Azadi Ka Mahotsav, but definitely to lead any movement, a great movement, a scientific temper is always required. So I believe though their education, the leaders of India, those who have contributed largely in the freedom struggle, they also must be driving by a scientific temper in their mind. Today's world, where I see that children are losing that the importance of freedom struggle, how to put them back to the mainstream, that what is the role of the modern science and how our great freedom fighters have worked together. We have to somehow mix the two things together. The schooling education, role of scientists, role of education, the freedom struggle. Though the three lectures which were given today, especially on the nano science or nanoparticles, I believe more such programs are required for the school children. Definitely college children are getting a lot of exposure through these labs, the CSR lab which has spread across the India. But more exposure has to be given to the children of schools. As was rightly pointed out by one of the speakers, that Prime Minister is talking of Atmanirbhar Bharat, self-reliant India. It can be done only if our new generation are becoming more and more skilled education. The present education is somehow, I believe, is not fulfilling that requirement of self-reliancy. So I feel that the internship program which is going in the college education right now may be, brought down to the school level as well. Some of the children, those who are very good, they have very good scientific temper, they have a lot of good exposure. If they are giving a compulsory internship program during summer vacation, probably it will lead to more, inventions in the basic science. After class 12, most of the children, they are willing to go either to the engineering side or to the medical side. But the basic science is somehow being neglected. So with these programs, I believe there will be more children who pursue their study in the basic science, physics, chemistry, or maths, and later on they will turn themselves to become a good scientist, and they will, contribute in the development of the country. So thank you, Mr. Mishra, for inviting me and giving me the chance to interact with the scientist. And I'm looking forward to work with the CSIR-AMPRI to have some more program for the children of Raipur region, especially because right now most of the program which I heard from my office, that most of the program which were done was for state-wise. But I will coordinate with you further that some more programs could be done for the children of Raipur region itself, and so the more and more children get exposure to this new scheme which we have started a few years back under Jigyasa. Thank you.
Sorry. Thank you, sir, for a nice talk. Now I would like to invite an eminent researcher and magnificent personality, Dr. P.S. Okan, Chief Scientist, CSIR-AMPRI, to deliver vote of thanks. Dr. Shokan sir, please.
आप सबको नमस्कार.
Namaskar.
Yeah, in fact, it is a matter of privilege for me today to say vote of thanks on these very important occasions of Azadi ke Amrit Mahotsav and the CSIR at the completion of 80 years. I extend my special thanks to our director and the organizers for giving me this opportunity to say vote of thanks, as well as I may have to slightly shortly sum up the programs of today also. First of all, our sincere thanks to our chief guest, Professor S.N. Raghuvanshi, Director, Maulana Azad College of Technology, Bhopal. Sir, we are very much impressed and learned many important aspects on Azadi Ki Amrit Mahotsav from your inspirational inaugural address. We felt that you are ever source of support for us in this institute. From your address, we could able to collect and gain about various in terms of the value of freedom and the necessity for its celebration and the glory of our achievement. As we exactly said, we are fortunate and we are currently in the front line nation, and we are proud of our stature, our industrial advancement, our technologies in terms of either computing technologies or other industrial innovations. Yes, we are proud of CSIR innovation and technology. In fact, it starts with the CSIR Amul milk powder and many more achievements as we have indicated, and moving forward towards the technology transfer and R&D transformations. As our chief guest highlighted, CSIR-AMPRI and MNIT Bhopal is having a very good collaboration and association, and we will be happy to have such association and continue and make great value to meet the Atmanirbhar Bharat and the Government of India missions. Sir, we are fortunate to have you today as a chief guest on behalf of our director, as well as our family members in the institute. I wish to express our gratitude for accepting our invitation and creating your valuable time, irrespective of your many other responsibility and commitment, to come to present and address to the gathering in the inaugural session. Thank you very much, sir. I think now we have another important milestone today in these programs. We have our distinguished guest, Dr. Piyush Dia. He is from University of Technology and Applied Science from Oman. Sir, you have been kind enough to accept our invitation in a very short time to deliver the keynote lecture for the today event. With your vast experience on industry education and multidisciplinary core material science, nanomaterials, modeling, nanoparticles, physics, and microscopy, and really listening your lecture is rewarding. In fact, we would love to learn and recollect many aspects of material science, including Moore's law and beyond Moore's law. And there is various aspects we could be able to refresh that include insulating properties, conducting properties, one-dimensional and two-dimensional electronic system and their significances. It is really very interesting to remember about Memristor and its characteristics. It's good learning, sir. As you said, Memristor can work like a human mind and has application in robotic and artificial intelligence. And I am sure today the Children's Society teachers, they might have enjoyed a lot from your inspirational speech and talk. Today your talk on computer computational material science and artificial intelligence, especially on future perspective, is ever memorable for us and is very important in the present and future program of this institute. I am confident today your visit to CSIR-AMPRI and keynote lecture would create a new R&D business between CSIR-AMPRI and the University of Technology and Applied Science, Oman. On behalf of our director and staff, I sincerely thank you for sparing your important time to come to AMPRI Bhopal all the way from Oman and sharing your experience. Thank you very much, sir. Today, we are also very much fortunate to have with us Professor Krishna Biswas. He is a Department of Material Science and Engineering, Indian Institute of Technology, Kanpur. It's really very exciting to learn from you, sir. Your lecture topic, why nanomaterials important, and on today as well as on tomorrow world. Our learning started from various use of titanium oxide nanoparticles for the road surface marker to photovoltaic, and also mesophores to nano device. Your competency on nanostructured materials, energy materials, particularly on size effect of ionic nanoparticles to nanotechnology, and the graphene and the graphene hybrid materials are very much impressive and really very rare learning chances to participant to learn, particularly the children, and we are fortunate to have you today with us in learning and understanding the importance and significance of nanomaterials with your unique explanation. I am pretty sure our scientists want to have more collaboration with you for the mutual benefit in the immediate future. Thank you very much for being with us and delivering your talk today. And today we would also enjoy listening to Dr. Rajni Verma, a young scientist from another continent, that is School of Physics from University of Melbourne, Australia. And we are very much impressed with your presentation and your lectures on nanomaterial, particularly on futuristic approaches on biological and environmental perspectives. It is very interesting and pleasure to learn recent advances on nanomaterial, especially from the Melbourne, Australia. We highly value and appreciate your time, Dr. Rajni Verma, and we thank you for sharing your knowledge. Thank you so much. And again, we are coming back to GKS programs. It's a really unique platform today. Today, we have the 4 deputy commissioners with us from Jabalpur, Raipur, and Bhopal. This is very rarely, this after COVID challenges for the personality like deputy commissioners, where the school is going to start and they have to plan many things to organize the school educations after a long time, how busy they used to be there. Irrespective of all these situations, we are here today, Mr. P.S. Sarkar, the Deputy Commissioner from Navodaya Vidyalaya Summit from Bhopal region. And we have today with us Mr. Somit Srivastava, a Deputy Commissioner from Kendriya Vidyalaya Sangathan from Bhopal region. And we have with us today Mr. Tajuddin Sakya, Deputy Commissioner from Kendriya Vidyalaya Sangathan from Jabalpur region. I believe Mr. Vinod Kumar also is joining with us and could not able to see. He is from Raipur region. Sir, our sincere thanks to each one of you for sharing your thought and understanding on GKS programs and your kind cooperations. Each one of your speech and sharing knowledge on Indian education, the educational policy, the literature, the women education, the socio-economic standard, the current scenario and the need of change and the traditional knowledge system is really very impressive. We highly value your significant contribution to the children's society, and we highly appreciate the dedicated services of your teachers in nurturing our children with the global standard and gaining benefit from R&D innovations and the GKS program of CSIR of Government of India. Thank you once again to all of you, sir. And finally, it is a matter of pleasure to say vote of thanks to my director, Professor Abnesh Srivastava. Really, I am weightless to express the way in which you keep us happy, the way in which you make us to perform the best with a quick outcome, the way in which you support and guide our scientific community to meet the national expectations, the way in which you connect us with the industry, stakeholder, entrepreneur to integrate a joint mission for the benefit of our nation, the way in which you transform our R&D outcome for the commercialization and make benefit to the industry, society, and environment. Really extraordinary directives and executing everything in a very pleasant approach. Sir, I am pretty sure the participants they are seeing here, all participants agree with me as you all carefully listening to his opening address as well as the welcome remark and subsequent documentary film on CSIR-AMPRI achievement, as well as how he is watching us since the start of the program and monitoring us in this program very minutely. Simply great. Sir, on behalf of our AMPRI family and my personal behalf, I take this opportunity to sincerely thank you for your very dynamic leadership, directives, support, and motivation for each and every program of the Institute. Thank you very much. A special thanks to Dr. Akram. In fact, he is a man of this event today, who has done the entire arrangement very quietly and made it very dynamically. And I have no words to express. Dr. Akram, thank you so much for your robust way of actions. Also, I appreciate and thank Dr. Sarika Verma, the principal scientist, for the effective conducting this program very effectively. Furthermore, the Jigyasa champion, earlier Dr. J.P. Shukla, the senior principal scientist, as on these days, Dr. Sadanand Mishra, who is a senior scientist at AMPRI. I think last 4 or 5 years I am seeing is doing extraordinarily integrating the school children, the teachers, and our R&D to really benefit to the children's society and the nation interest, who deserve a special thanks for connecting our children's society and teachers and academic and stakeholders as part of the skill development program and the GKS programs. Thanks to all my chief scientists, CSIR-AMPRI Bhopal, all our IT teams, and the family of CSIR include the scientific staff, administrative staff, project staffs, PhD scholars, and all the participants. There are many children, students, teachers, and guest speakers, stakeholders, government industry officials participating in this event and celebrating and enjoying the Azadi ke Amrit Mahotsav. आप सभी के बहुत बहुत धन्यवाद for making this program very successful. Once again, thank you all. Namaskar.
Thank you, sir, for you have enlightened us. I request to our director, sir, to final conclude the session and in the reward.
Thanks to all of you, all participants, chief guests, guests of honor, invited speaker, eminent speakers from Kendriya Vidyalaya and Navodaya schools, all those who participated directly, indirectly, then maybe I'm a face from AMPRI, but the people who are working as a team from AMPRI, they deserve more appreciation for organization of this today's event. You know, everything when it goes well, I mean, we forget what is the homework behind that has been done. So I must thank to IT team, Dr. A.K. Singh, Mr. Hirwar, Mr. Naren Singh, and the coordinators, Dr. Akram, Dr. Sarika, and even the people whom name I'm not aware, but they have worked behind that. And the entire support staff of AMPRI. And of course, the speakers They have joined. I can see that in Australia it must be 11 plus sometime, but she is still there and smiling. And the other speakers, Dr. Piyush has come all the way from Oman. Then Professor Kishanu Basu, Vishwas. All these faculties are very busy in teaching, that too online teaching. It's first time we are having this kind of experience. COVID has taught us to do so many new things. And our all deputy commissioners, they have sat all the time throughout the program. And they are the real linkage between the young school children to the scientists who are in the lab. And they are the real bridge actually working between the children and the scientists and faculties. So thanks to everybody. Professor Raghuvanshi gave his very valuable time as chief guest because I know his schedule is very, very busy. He's having a lot of other responsibilities in addition to manage. So I must thank from core of heart to all of you for making this program very successful. And let's hope keep meeting, and maybe some other time when COVID goes off, we can meet physically in AMPRI with same team, maybe after 6 months or 1 year. Thank you very much. Namaskar.
Thank you so much.
Thank you.